is I try to convert them to improper fraction first. So I'm going to just change everything. So I'm going to go 7 times 1, 7 plus 4, that's 11 over 7 plus 2 third minus 6, 1, 6 plus 5, 11 over 6. You can do them one time, or whenever you're adding or subtracting, can be done at the same time. If you're adding or subtracting, if you want, it's up to you. Or if you want to do them piece by piece. So let's go piece by piece. Most persons would have done it piece by piece. But you can't do everything one time if you're adding and subtracting. But here it is. The LCM is going to be 21. 70 to 21 goes 2 times, goes 3 times. 3, 11, that's 33. 3 into 21, 7, 7 twos, 14. So we want to add 14 and this, we're going to get about 47 over 21. All right. So we want to quickly add those. Then now we're going to subtract 11, 6. So we have 47 over 21, and you want to minus 11 over 6. 42. 21 to 42 goes 2 times. 2 times 47, that's about 94. 7, 77. So 94 minus 77, that's about 17 over 42. All right. All right, so there you go. All right, so we would have collected 2 marks. All right, 2 marks easily for that. Let's go to the next question. Now, with the next question, it says here, write the value of, and let me look if this is big enough. All right, write the value of the third root of 27 over the square of 9, right? We're supposed to write the value of that as a fraction in its lowest term. And you always want to make sure that you follow everything that they say. What does the third root mean? So you could simply ask yourself, what number? So the third root of 27 is actually asking for what number multiplied by itself 3 times to give 27. But this is 3. Because 3, if you should check 3 multiplied by 3, multiplied by 3, you will get 27. So it means then the cube root of 27 is 3. And when you square 9, you get 81. Now, this is not the final answer because they want you to put it in its lowest. And 3 could go into itself 1 time, and 3 into 81 about 27. So the final answer for this is 1 over 27. All right, so that's the final answer. That's another 2 marks. All right. It says, so this one says the thickness, right, of one sheet of cardboard is given as this. That is the thickness and it is in millimeter. All right. A construction worker uses 75 of the cardboard. So this is the thickness, and they use 75 as that of that put together. And now they're asking us to show that the exact thickness of the insulator is this. All right, so basically it is simply 485 times 10 to the negative 2 if you multiply that by 75, because they did say they get 75 of that. All right, so if you could put that on your calculator, fine. If not, you wanna convert this to decimal and then work. So basically then, if you convert this to decimal, then it's gonna give you 4.85, then you multiply by 75, because this part as a decimal is this. You multiply that by 75. And you will get 363.75. This is in millimeters, which is what they were asking. So all you have to do is to read the question and then respond to it. It's not a big deal. Right, the thickness of the insulator, two significant figures. Now, here is the thickness of the insulator. And they wanted to put that to two significant figures here. Remember the principle behind your significant figures. You want to identify the digit that is in the second spot, which is 6. And then what you want to do is, because they said two significant figures, you're going to look to the right of that spot, and the number to the right is 3, which means that it's in the category of 0 to 4. So you're going to have to round it down to 360, right? So to two significant figures, the thickness is 360 for your final answer. They want us to write that to one decimal place. Let's look at the original number. It was 363.75. And they want you to write that one decimal place. Then the idea is that you're gonna look at the digit there, that's a 7, and then observe the digit to the immediate right, and it's in the 5 to 9 category, so the spot is going to go up. So this one will be 363.8. All right, so this would have been the answer to one decimal place. In standard form, take back a look at the original. In standard form, the decimal point must come after the first non-zero digit. So you want to start off by putting that decimal point between the 3 and the 6. You want to write back all the other numbers and you say times 10. That's the general framework. Then you want to check to see how many places did the decimal point move to get here. So it moved 1, 2 places to get there. So that means this is a 2. And since the original number is a number bigger than 1, it's a positive count. All right, so there it is, 3.6375 times 10 to the second power. All right, guys, remember to ask the questions, ask the questions. Remember, this is not YouTube. You're in a regular class session. So the questions will be live, right? All right, the C part of this question says here that Marco is on vacation in the Caribbean. He changes 4,500 Mexican pesos to Eastern Caribbean dollar. He received 630. Now complete the statement below. You want to know what 1 Eastern Caribbean dollar is in Mexican dollar, right? So basically, you want to take this. You want to take this 4,005 here, Mexican money. You want to divide it by 630. Make sure you do this on your calculator.
7.14, sir.
7.14. All right, good. So this is yourself 1. This is going to give you 7.14. So it's in money, so they have 7.14. And that's it. So 1 EC dollar is 7.14 Mexican money. So it's a 1 mark question, but number 1, I think, is now finished. 9 marks. So that was what the number 1 looks like for that year. All right, here's what the number 2 looks like for that year. It says factorize your expressions, right? So we're looking at 4 and n as the highest common factor. So we'll get 3n minus m close 1 mark. All right, let's look on this question here. It says, show that x over 1 minus x minus 4x is equal to all of that. You're supposed to show. I would suggest that the moment they ask you to show, that means it is equal to it. So what you want to do is to take what you have on the left side. So you see, I put a 1 over this so you could, feel a little bit better. And you want to take this and do your algebra fraction that you learn whenever and see what you get. Now, remember now, when you're adding or subtracting, in this case, you're subtracting fractions and the denominators are not the same. All right, you use the LCM. The LCM is going to be 1 minus x. So 1 minus x into itself is 1 time. 1 times x will give you x. 1 into 1 minus x is actually 1 minus x. All right. So now if you should do your quick distribution with this negative 4 to that, this negative 4x should say to this. Let's carry those out. Negative 4 times 1 is negative 4x. Negative 4x times negative x will give me positive 4x squared. Right? So then that's what I'm having right now. So when I distribute, this is what I have, and you want to make sure that you don't mess up this. It's going to change what that 4 is. So it's a negative 4x times 1, negative 4x times negative x. Now you want to simplify the top. So at the top, they are like terms. I could highlight them for you. These two things are alike right there. All right, so that those are alike. I'm going to rewrite everything. 1 minus x. I'm going to put the 4x out first. And the x minus 4x is going to give me negative 3x. Now you want to take a look at how they have their answer. You're going to do everything to write your answer like that. So again, at the bottom, it's 1 minus x. But at the top, you're going to have to factorize out x to get yours like theirs. So you're going to factorize out x, open a bracket. So when the x go into 4x squared, you're left with a 4x. And when the x goes into negative 3x, you're left with negative 3. And look at it. You have just proven or shown that this is that. So that's you looking at what they have, and you take your time and you do yours until it looks like that. Any questions? All right. All right. You should notice that they are like writing stuff like these a lot. So they would say, hence, solve this. But when you look at this, definitely you're going to notice that, hey, this is what I just did. This was what I just did. Hence, solve this. Now, hence would suggest that you need to go back for your answer, and this is your answer. Hence refers to the fact that you need to go get your answer just now, which is this. Hence, so you're going to get your answer. So you want to rewrite this. So it's going to be x, open bracket, 4x minus 3 all over 1 minus x. So you just replace this idea with what you had gotten when you were working it out and let it equal to 0. Now, what you want to do here is that you want to start working because they want it to solve. So they say, hence, solve. So you reproduce this in another form that you got. The word hence would suggest that you have to use back your answer to solve this problem. Hence. So we wrote back our answer, let it equal to 0. And from here, you want to multiply both sides by 1 minus x. Now you're going to notice that on the left side, 1 minus x would cancel itself. So what you're left with is x, open bracket, 4x minus 3 is equal to 0 because this is going to be 0 as well. 0 times anything is 0. So you have this. Now, because two things multiplied, which is this along with this, and the result is a 0, then you could say either my x is a 0 or the 4x minus 3 is a 0. And for the second piece, you do your regular solving, whichever way. So 4x is equal to 3. And then you divide both sides by 4. So you could see that x is equal to 3 over 4 or 0. So those are the answers there. So basically, you have to read what they have and look back at your previous questions to take yourself to the final thing. So it means then if you had gotten some messed up, well, you would have known if you did not prove it though. Because remember the question before that forced you to show that it's equal to this. And then you went back for that final answer to solve the problem. All right, look at this one. It says make V the subject of the formula. So if you notice here, we have P, which is equal to the square root sign, and we have 5 plus VT under there. The intention is to focus on the V, but the V is actually under the square root sign. So we won't be able to do anything until we actually start squaring everything first. So we want to square both sides. So you want to do this. So we square both sides here. So P square is now equal to 5 plus VT. Because when a square and the square root clashes, which is right here, when a square and a square root clashes, they both just, cancel out each other. Remember the objective is to get the V alone. So we're going to leave this for last and remove any else thing on that side, which is a 5. It's a plus 5, so you want to subtract 5 from both sides. So in our rewriting here, we'll have this. And then now finally, to have V alone, we divide both sides by T. So you could see that V is equal to P squared minus 5 all over T. The distance needed to stop a car. So we're looking at another question. It's a part of number 2. Remember, I'm going through these questions so that you could have a very good idea of what is to come. It's the same ideas. All right, this is a very recent paper. So you could see what type of question comes at the various places. All right. All right, so we're looking at this one. It says the distance needed to stop a car, D. The distance needed to stop a car, so D is for distance, varies directly as the square of the speed. Anybody remember when we were doing variation, this statement is very important. The distance needed varies directly, so we're doing a direct proportion here. All right, so it varies as the square of the car at which is traveling. All right, now the second part says a car traveling at 70 kilometers per hour requires 40 meters to make a stop. What distance is required to stop a car traveling at 80? All right. Now, In order to do this question, you want to set up the formula for your variation. The formula, based on what you got in the first sentence, says that D varies, and I'm going to put K, the speed, all right, square. It varies directly as the square of the speed. So that's my formula for the day. Now, in order to solve these variation problems, they're going to have to give you something that worked already. So if you look, you got a speed already. You got a speed, which is 70, when the D was 40. So I'm able to use my first situation here in this formula, and then I'm going to find K, because remember, you need to find the constant of your variation early. Then you could use it to solve other problems. So let us find the constant now. So substituting, we're talking about D. D is equal to K S square. D is 40 is equal to K, which is what I don't know yet, times S square, which is 70 square. Continue working. 40 is equal to K times 4,900. So if I divide both sides by 4,900, then you could see that K is equal to, I could just put 4 over 490 if I want, or I could put 40 over 4,900 if I want. All right, since it doesn't look like it can go into it fully without a remainder, and I'm afraid to use the decimals, I don't want to round off anything. I'll keep that, right? So that I'm not rounding off the answers. It might spoil something in the end, but it's fine. Right? So there we have that. Now, so here's the answer. So you could break it down, as I said, it's up to you. It's fine. What if you want to break it down? You could get 4 over 490, or you could break it a little further. This becomes 2 over 245. Anyone you want to do, because it's the same thing. So if you want to break it down to that, the value of K, you could use anyone you want to use. It's fine. Let me repeat. You break it down. The question is not going to penalize you. You can use anyone that you're comfortable with. All right. So at the end of the day, I'm going to choose one. Whichever one I choose, it's the same answer that we're going to get. So there is K. Now that I know what K is, then I can use it to answer the last question. Because in the last question, right? So let me bar this off. In the last question, this is what's going on here. All right. The last question, we still have K. K is the constant. It's not going to change. So I'm going to write 2 over 245 for it. That's K. And they gave us a speed. We got the speed, which was 80. And they're asking what distance. So the D is what we don't know. The formula says that D is equal to KS square. So that D is going to equal to K, which you could put 2
Sir,
over
is it 70 or 80?
All right. Whenever you're doing variation, they're going to give you 2 situations. One where you will get the 2 variables and you use it to find K. For example, you got a case when 70 and 40 were walking together. We use that over here to find a value for K, because K is important. Now, then they're going to ask you a question after that. Here is the question. What distance? So you realize you don't have B. What distance is required to stop a car traveling at 80? So you got the speed. You got the speed in the second question. Matter of fact, you got the speed in the only question that was asked, and you did not get D. They're asking you for D. Tell me if you see what's going on.
Yes, sir.
So they are just asking you that. So what I'm saying to you is, the moment you're doing a variation question, you must first find K, or what we call the constant of variation, right? So it's a constant of variation. It's called K. In this case, I use a K, all right? Any letter could work. So they would give you two things that work. You use those to find K. But after that, they're going to give you one thing to find another, which is what we're doing here. The rescue is that we will have a value for K that will not change. The difference is that S will be changing, D will be changing, K will remain the same. So in one instance, your speed was 70, and in the next instance, the speed becomes 80. D was 40. We don't know what D is now. They're asking us to find it. So you set it up in the same formula, but the variables are changing, except the constant. So this is what you have there working. If you put that together on your calculator, you should get the answer. So basically, 2 times 6400 over 245 is the answer. And you put that on your calculator and work it out. $52.2. Meters. All right, so conclusion about variation, you're going to get a situation with the two variables. Remember, you have to write the formula based on what they say. You write it up. You substitute those two things. In the beginning, find your constant of variation. And then they'll ask you a question where one of the variable you would not get the value. But because you just found the constant, you use your constant on one variable to find the next variable. And that's how the questions are every time. That's a typical number 2. And number 1 and number 2, as you could see, they come for 9 marks each. We're going on to number 3, which, as you could see, each time we do a number 3, if you look back when we did the marathon and so on, a number 3 is a transformation. All right, so it's a transformation question. So it says, the diagram below shows 2 pentagons, P and Q, drawn on the grid, made up of squares. You're seeing that. So it says, select the correct word from the following list to complete the statement below. All right. So the words that they have here, you're seeing the word opposite, reflected, congruent, translated. We know what translation is. We know what reflection is. And the opposite, the word congruent is the same as an identical twin. If you don't know what congruent means, it's an identical twin. And you know what identical twins are? They look exactly the same, no difference. You know what I mean? Now, complete this. It says P, pentagon P is dashed to pentagon Q. Now, you want to put one of these words there. Look at it. Pentagon P is opposite. No. Pentagon P is reflected to. No. Pentagon P is translated to pentagon Q. No, it's actually congruent. All right, you look at it, congruent means it's the same thing you're looking at, You might turn it around, but it is the same thing you're looking at. So it is congruent. All right, so it is congruent to it, which means that it is the same thing you're looking at. 1 mark for that. Now, the question says, give the reason for your choice. And as we say, when you're talking about congruent, you're talking about the thing being similar, look the same. All right? So you could say, all right, P and Q are similar objects of the same size. All right. So when we say similar, it's actually telling you that it's the same shape that they're looking at. And when you say same size, you're basically telling that every aspect of one is like the other one. All right. So if you don't want to use similar, you could say P and Q are of the same shape and size. You could say that they're of the same shape and size, some more simple words that you could pick from. But you want to make sure that you're putting out that it is an identical twin. And even if you want to say P and Q are like identical twins, those would work because we know what we mean when we say identical twins. 1 mark for that. Take a look. All right, here's another question. All right, this one is an aspect of geometry. It's going to mingle a few things as you could see. It says, diagram below, not drawn to scale, shows the pentagon VWXYZ. You could see that in the pentagon, YZ is parallel to XW. So I'm going to highlight, they're telling you that this is parallel to this. Also, they're giving us angles, and you're seeing it there. Information. And here's another set of parallel lines that they're showing you too, that this is parallel to that. So we have 2 pairs of parallel lines. So we could solve some problems. This is what they're asking. Determine the value of this angle, W, X, and Y. So follow W, X, Y. The angle is going to be right here that they want. So then, what you could do though, is to remember your co-interior and your Z angle and so on, because here's a co-interior. If I have 2 parallel lines like this, one going that way and the other going this way, if another line cuts it like this. All right, let me fix up my lines better. This is ugly. If I have 2 parallel lines, this is one. And let us say this is another. And wow. Because these lines are parallel, it makes this angle plus this angle add to give 180. It's called co-interior. So this angle here and the angle that they want add to give 180, because look at the 2 parallel lines in blue. See it here? Parallel, parallel. They are parallel. So then what we want to do is to see that they are parallel and then link it to co-interior. So this angle is going to be 180. I want to take out 114, and then that's going to be my answer. So we get 66 degrees. Just like that. So as you can see, you just have to remember your little parallel line is cut by another line. We kind of went through that some time ago. So I'm going to put this in the corner here. This is 66. Now let's look at the next question. We want to find the angle ZVW. When you follow the flow of three letters Z to V to W, Z to V to W, they're asking you to find this. Now, when you look at this, you might not have a definite solution for it right now. But there are 5 angles in this figure. If I can find what this one is, we could come up with a way to get it. For example, you do notice that we have another set of parallel lines again. Look at this. Imagine that this line parallel to this, and it's cut by this. So this is now a transversal, which means that the angle at W and 66 are co-interior as well. Because as long as you have 2 parallel lines like this, look, we have that one going that way, and then this one coming this way. Then if this is 66, if I take it from 180, I'll get that. Just like that. All right. So because we have those parallel lines, then I'm able to find this angle to be 114, because I'm going to say 180, take out 66, and it's going to give me 114 degrees for that. Now that I know 4 angles out of 5, I can now find that angle that the question is asking for here. Before I found 114, I wasn't able to. But now that I have that, I'm able now to go there. Now, here is the deal. When you have a 5-sided figure, right, you want to know the total angles that are inside. So I'm going to quickly show you an idea. So for learning, I'm just making up a 5-sided figure. If you have 5-sided figure, right, you want to know the total angles inside, because if you should add up this plus that, plus that, plus that, plus that, there is a certain amount of degree that you will get. If it is a triangle, it's going to be 180. If it is a quadrilateral 4-side, it's 360 and so on. But a simple way that you could know is to find out how many triangles you could get if you should stand in one corner. So if I should say I'm standing up at this corner and I want to create triangles with a straight line from my corner, I would be able to create from that corner, I'll be able to create 3 triangles from a 5-sided figure and no more. Standing at one corner, try to create triangles. You realize that, oh, I could draw 2 lines, which means that I could get 3 triangles. Now, the total angle in every triangle is going to be 180. So then, okay, the total angle here is going to give me 180. The total angle here is going to give me 180. The total angle in there is going to give me 180. So now I'm able to understand that for 5 sides, I could tell the total. So it's going to be 3 times 180, because I'm able to get 3 triangles. So my total angle here, and I'm going to put total interior angle, it's going to be 3 times 180, which is 540. A lot of people would just have this. You don't have to show CXC how you get it. This is me showing you how to get it. And it's not just for a 5-sided figure. It's for any sides. You are able to, if you can't remember what's the total angle in any side, like a figure, then you could find out by dividing up the thing into triangles. But remember, you have to stand at one place. Don't move. So you pick a spot and then try to create the triangles. And every triangle is at 180. So now that I know that I have 540 degrees, I could find that missing angle up here. Because I'm going to say this. 540 is the total, and I'm going to subtract the sum of every other angle. There is a 98 plus 114. There's a 66 and another 114. So I'm adding up all the angles inside, which is 4. And I'm going to add it up, take it from the 540 to get the last one. So you want to make sure that you put your total together. So we have 540, and you want to subtract a total of 332. And it's telling you that the answer is 208 degrees. That angle all the way over here is a 208. Because all the angles on the inside should add to give 540. So that's the clue right there, knowing that. But what we looked at was just a way in which I could tell the total angle in any figure. Right? The total angle in any figure. All right, let's make sure, right?
Yeah.
Let's make sure that we double check to get the, double check for me.
I think it's 392.
All right, let me add it over because I'm checking it. That's what I was saying. Let's check it first. Hold on. Yes, 392 sounds good. I wrote a 349 right there. All right, good checking, Miss Scott. Let's subtract that now. 392. I'm getting about 148. Yes, very good looking out. All right, so you have to make sure that you check properly because every now and then your hand might put something, right? Very good. All right, let me put it on the diagram here. It's 1. And when you're writing the wrong thing, you're not going on, you know. So it's good to double check. All right. Very good. Thank you, Miss Scott. All right, guys, these are the questions that are coming in. This is it. All right, this is an enlargement. I don't think I can do here. I probably want to take it to the next board. Let me see what. All right, let's look what they said. All right, here's as you can see, as I said to you, transformation comes at number 3. Look, they start you off asking you. You could see that they're coming with the transformation. You're looking at that, but they didn't ask you yet. They mess around and do a thing and watch. So geometry comes here, regular geometry, shapes. And then here, is your big transformation question, right? So it's a number 3. It could come at number 10 as well. But here it is at number 3. It says the letter A and a point C66 are shown. You can see that they are saying, hello, see there? Those are what they are shown here, right? You're seeing that. All right, now it says on the diagram, draw accurately each of the following transformation. 1, an enlargement of the letter A by a scale factor 2 at the center 66. All right, remember we looked at enlargement. Then now after that is saying they want you to translate A, all right, using -3, 2. All right. We could do the translation quickly. Let's do the translation here, and then let me do the enlargement on the other board to kind of make sure everything meets. All right. So I could do the translation here. Oh, no, you know what? Let's bring everything to the other side. Hold on. Let me just do that. Let me copy it and bring it to the other board. Because remember, we can manipulate the other board. We can't manipulate this that I'm working in, but definitely I could get way more accurate answers when I go here. The question could stay. You just want to have this over there. Let's go. Here it is. All right. So we could blow this up now. All right. All right. So this is good to work with. All right. Now we could flip back and forth now just to look at what the questions are. Right. So there's the question. Let us flip, working. All right, good. All right, question. On the diagram, draw accurately each of the following. So let's do them in order. It says the enlargement of letter A by scale factor 2, center 6. So remember, if I have the center already and the scale factor must be 2, all I'm going to do is to take a long line and run it through. Remember, we said that in. All right. Taking a long line, you run it from the center to some key places. I'm just putting in some key places. The key places are there. Key places. So I'm running it. I'm running it through 3 key places. All right, not seeing that line. Let me look again. Let me draw it again. All right, there it is. All right. So if you notice, I'm going to do the enlargement. Remember, the key idea is if you give me the center already and you give me the object, I'm just going to draw a line, right? From the center through the key areas, those little areas. I just need those 3. All right. And I'm going to recreate the idea, basically. But remember now, it's gonna double up because the scale factor is 2. So scale factor is 2. So you want to have that in your mind, man, that the distance is going to double up for each. And we could look at the ideas, you know. You could look for yourself and because remember, this is where the center is. So you're gonna journey go that way to double up each time. So if I'm doubling up, the distance is like from here to here. I think it's gonna land about here. Imagine you double it and you come here. Yeah. So that spot here will now be here. Think about that. Just look at the doubling of the distance from the center. Doubling. So you wanna do that, and then look again. Look at the other distance here from here to here. Follow on that same line. Double that, and you will land about here. Look at the double. Literally, you can take a rule and measure, and it's gonna land at the nice place, you know. So it's gonna land here. All right, let me use a red. Let me use a red to show you where I'm landing. First one is gonna land here. The second one will land here. And you could see where the third one is gonna land. It's gonna land here. Real. Look at this distance from here to here. Double it up on the same line. You could see that it lands here. Look at that. That's all I'm doing. I'm just doubling up because it's 2. Doubling. See there? Double that distance. You could see that. Oh, you're seeing them because the idea when you're doing your enlargement, you're going to have the center, fine. And I have the object, draw the line through the vertices and then just double because the scale factor is 2. That means double. If it was a half, you know what to do. If it was a 3, you know what to do. So now I'm going to recreate this shape easily. Watch. There it is. There it is. There it is. That's your, yeah. All right, just stop for a moment. Are we okay with that? The idea of doubling, because the scale factor is 2, you had to double. The distance from the center, fine. You understand? When the scale factor, when the center is 0, 0, it's a different approach. It's the same approach, but you have more options. But when it's not 0, 0, I mean, you can focus on just connecting a line from the center through the various vertices, and then you double or half or triple, depending on what the scale factor is. And you do see that it gets bigger, 2 times as big. All right. Let's look at the next question. It says here, you want to translate the letter A, its original letter, using the vector -3, 2. All right, so we're gonna let me take off these. All right. All right, so you're gonna move A, and you wanna move A using, here it is, -3, 2. So all we're gonna do is move each point again. So you're moving this -3. So T is -3 with a 2. That means we're gonna go 3 places to the left and then 2 up. So you're moving like that. That's the movement. So you're gonna go 1, 2, 3, 1, 2. Here is the new location for A, for the top of it. Then we're gonna go 1, 2, 3, 1, 2. We're gonna have a spot there. Then we're gonna go 1, 2, 3, 1, 2, and we have the next spot there. Same idea, I know. So I'm just going to do a freehand now. You would have done this. And you did this. And that's it. Use another marker. But you would have used a ruler. There it is. You translate it up there. So if I should take off back these. All right, you know what? Let me take them off so you could see the diagram better. Hold on. So when you move it, the diagram comes here. That's fine. And the move come up here. That's it. All right. And as I said to you, when you're doing like the transformation questions, as you could see, these are ideas, it doesn't get harder. We complete transformation already. Here is a question, and you should feel comfortable as long as you're going over your stuff. The same things that you did in class, exact things, same things that they want you to do. All right. And here it is, 9 marks are telling you that, hey, it's 27 marks we've gone through already. All right, look at number 4 now. All right, so you're seeing number 4 comes in a function form. So if the function is going to come here, it can come at number 4, as well as function can come at number 8. So it says the function f is defined as, this is the same thing as saying f of x is equal to 3 minus 2x. All right. So that's the same thing. So when you're interpreting this, it's the same thing. So just say f of x is equal to 3 minus 2x. The question says the diagram below shows the mapping diagram of the function, determining the value of a. And you're saying this is a mapping diagram, which means that you're seeing the x and you're seeing the f of x. F of x is another way of saying y. the arrows will always be coming from where the x is going towards f of x or going towards the y, right? So something would have happened to number 2 and produce -1. In other words, you would have plugged in number 2 right here, and when you work it out, it gives you -1. Then you plug in number 1 here, work it out, and you got 1. You plug in the 0, work it out, and you got 3. So technically, they want you to determine A. You want to understand that all you're doing is, here is the function, right? You're going to input, so this is our input. And when you put in the input, you get out here what we call your output. Your x value is your input all the time, and the result of it is y, or they sometimes call it f of x, right? So then, this is the function. This is the program, 3 minus 2x. We're supposed to plug in -1 in that program as an input from your x, and it's going to tell you the value of a here. So you do your regular workout. This is 3 plus 2, and you do get 5. So a is 5. Take a look at it, see if you're okay. All right, so A is 5. Continue. It says, determine in their simplest form expressions for the inverse of the function. All right. So they want us to give the inverse of the function. So here's the function. F of x is equal to 3 minus 2x. And they want us to give the inverse of it. Remember, we had suggested that when we're going to do the inverse, we want to let, I always write this, I want to let f of x equal y. All right, so I'm going to let f of x equal y. And you don't have to write out this wording. This is from me to you. So I'm going to let f of x equal y such that y is equal to 3 minus 2x, because I'm replacing it with something that I need. We need to speak about y. So I'm just telling the examiner that I'm going to let f of x be y, right? Then no, there's a two-step process. One, you're going to switch x and y, and then you transpose for the new y. As you could see, you're going to have to maintain this, leave this for last. So what we're going to actually do is to get rid of the 3. So we'll subtract 3 from both sides. So I would have an x minus 3 here equal to -2y. Basically, I'm going to divide both sides by -2. So you could see I have y, but nobody asks you for y. So you're going to have to rewrite the thing and tell them that the inverse. Because it's the inverse you know that you're finding. So at the end of the day, you're just going to answer the question. So x minus 3 over -2 is your inverse. There it is. Now, let us say that you want to, so that's your inverse. As well as it could have been written another way. All right? Meaning, like when you were solving, it's up to you what you could do. And let me show you what I mean. Let me show you, because people feel differently sometimes. I'm going to put it in a box. This is perfect, but I could do it another way, and you might wonder if it is the same thing. It is the same thing, but look at this. Say you have y, which is equal to 3 minus 2x. You could have done this. When you switch, you could have brought the y to the other side and bring the x over. Like you could have brought the y over here so that the 2 becomes positive, and then you bring the x over here. So then if you had done that switching, you would have had positive 2y equal to 3 minus x. As I said to you, bringing the y on the other side, it turns from a negative 2 to positive. That's fine. And the positive x becomes a negative x. Yes. And then you divide by 2. So you would have had y equal to 3 minus x over 2. So you would have given this as your answer if you did it that way. And it is the same thing. If you try to put some number and work out, you get the same answer. So I'm saying, don't feel weird when you see other people with other answers. Both of you can be correct and don't know. So this is correct as well as that. And you see, it looks a little bit different. But you could see that one is just the negative. You could see the double negative switching the stuff. So it's good. Both of them are fine, right? I just felt like pointing that out because you were able to keep your y on one side. Somebody might have brought it on the other side, but everybody would still be okay as a final answer. All right. The composite function f, we know what this means. If I'm given f squared, it means to put f in itself. We have been looking at ideas like this for a while, and I realized that quite often they're giving us these to do because people tend to do the wrong thing. When you're doing function, the square of a function means that the function goes into itself. So if we should write back what the f function is, all right, so f of x is 3 minus 2x. And if I'm going to do this, which is this is this, so I understand what it is. So then I'm going to put the f function into itself. It means that wherever the x is, I am going to drop that f function. You're going to put the function in itself. There is only one place that you can do that. You can only do that where the x would be. All right, so it's like we have 2 times x. So it's going to be that 2 times the entire function again. So that's the function going into itself. And then you employ your regular math. Negative 2 must be distributed. So here it is that we'll have 3. Negative 2 times 3, that's negative 6. Negative 2 times negative 4. Negative 2 times negative 2. X will give you positive 4 with an x. And so what you want to do now is to simplify the idea. So let us say I put the x part in front. All right. All right, hold on. Negative 6, negative 4. All right, positive 4. 3 minus the 6. Okay. Are we good with that? So as I said to you, you are used to doing stuff like this. That's fine. But if they want to mess around with you, they will ask you about the square of a function. Remember, you are simply putting the function in itself you're going to do it the same way you would have done this one or that one. Please don't feel weird. Just take your time. Do what you have to do. All right, we're good. All right, for this one, I'm going to tell you now. The last time I did I think a question like this for you, I worked it out. All right, but let's take a look at this. It's given for 1 mark and it says state, right? So you can actually state the thing. So it's just a knowledge I'm going to give you now. I'm just going to give you the knowledge so you could learn to write this answer. So the answer for this is -2. If you have the inverse of a function in itself, if you should take a function, like any function, if I have the g function and I put the inverse of it in it, I'll get out anything here is the answer. This is just a little rule in functions. So you could just note that down. Hold on. So if I put a function in itself, any value that I put in that function, like in the inverse, if I put the inverse in the function, any value that we have is what will come out. So like this one where we have the -2 and it's going with the inverse here, and that's going into the same function that it came from, the answer is just going to be -2. So in other words, then if you put what this means, and this is just for learning. Let me do something. Let me show you what I mean for learning purposes. Here is the function f. Yeah, we could just do this just for learning. You don't need to do this for anybody. I'm just doing this so that you can understand what I'm saying. That is f, and we found the inverse. Yeah, we found the inverse to be what? What was the inverse again? 3 minus x over 2. If I should take this and put it in this, the answer will be x. So if you should take the inverse of a function and put it back into itself, you'll get back x. So what it means, if you go in an exam and you see they give you this, and as long as it's a 1 mark they give you, that means they don't necessarily want to see you work it out, because you will get back the same answer here. So when they said state, basically it's like they're saying, just tell us. State is different from working out. I'm just saying, right? And if they said state, more likely they're going to put the 1 mark there. But you say if you want to work it out, that's fine. But you can just write what it is if you know. If the inverse of the function go back into the same function, any value that is here is going to be the answer. So I am just going to show you this by proving that I could put the inverse of f back in f now. And then you're going to realize that you're going to get x for the answer. Look. So let's do it here. This is the f function. So it was 3 minus 2x. This is the inverse that we found. And it is 3 minus x over 2. So I'm going to put f in the inverse into itself. So that means I'm going to be writing about that minus 2. And then now I'm going to put this function in it. It's kind of ugly, but sorry. Watch. So I'm putting the inverse in the function, right? So what I want us to look at now is, remember, these two things here are merging here. That's 1 because it's multiplication here, so nothing to worry about. It's multiplication because this is multiplication, multiplication, same thing. So the 3, I'm going to leave it there for now. But remember, that 2 is at the numerator. So I'm going to slide it in. So look what's going to happen. We're going to have minus 6 when I multiply this time this. And then, or you don't even have to do that. We could cancel. Hold on. Let's do less work. Let me do less work for you. You could cancel this 2 at the top with this 2 at the bottom. Right now. Let's do that. All right. So you see it cancel. So there's a negative sign left outside. Look, this is what we have now. Look. look what's going to happen now when I clear this up. 3, when this negative sign go in, that becomes negative 3. When the same negative sign go in, this becomes positive x. Look what happened. 3 minus 3 is gone, and you're left with x. What we're saying is, when you put the inverse of a function back into the function it came from, the result is just x. See, there are adjusters to prove right there. Now, why am I doing that? Just to give you this knowledge that in this case, you don't necessarily have to work it out. Look at the question. State the value of f of the inverse of f of negative 2. The answer is negative 2. That's all I'm saying. All right. The fact that you have the inverse of the function in itself, any value that is here will be the value here. And they're going to give a little, they're not going to give a lot of marks because now you learn, other people know. So they're not going to give you 3 marks or something that, oh, somebody who knows will just write the answer for. The thing is, you can work it out a long way though for them and they'll still give you a 1 mark. But the student who is aware will get the same 1 mark for doing no work. So that's just me showing you that, hey, this is that. All right, so the answer is negative 2. All right, what do we have here? Oh, can I draw these? All right, I'm not able to draw this here properly. If we want to do this, I think we have to take it to the right place. So definitely I could take this to the right board. All right, let me bring it over here. All right. All right, this is what we have. All right, so using ruler, we want to draw the lines. So the lines that we want to draw, if you're looking at it, one of the line is x equal to a half, and the other line is going to be y equal x, and the other line is x plus y equal 5. I think you might have seen a question like this already, because while we were doing marathon, I would have gone through and pick questions from the past paper for us to do. And I think we might have done this. Now, the question says, use a ruler to draw these lines. So this is my ruler here I'm going for. And I'm going to draw the line. First line is x equal a half. So I'm going to go on the x-axis, find a half, which is between 0 and 1. And I'm going to brighten this line. So you brighten this line if you were in there. I'm going to put a red so you can see it. That's it. So that's me drawing x equal a half there for you. And I normally label it for memory so that I remember what's going on. So I'm going to put, this is where x is equal to a half. That's the line. Everybody could see that. We're on the x-axis, it's a half. Draw that line. They want us to also draw the line y equal x. So we just drew this line already. They want us to draw this one now, y equal x. If you remember carefully, we spoke about the unique thing about y equal x is that there are specific coordinates on it. The x values and the y values are the same. That's why it's called y equal x. So it's a very unique line such that on it, every x value is the y value as a coordinate. So you could just simply draw your line through these specific places, like it could start at 0, 0. And you go through 1, 1, 2, 2, 3, 3. And I'm going to draw it as long as I can off the grid. There it is, right there. All right, that's me putting it right there. That's that line. So if you look on it, y is equal to x everywhere. Like, look at this. This is where 1 meets 1. This is where 2 meets 2. This is where 4 meets 4. And the list goes on. Y and x are twins here. This is the line that is called y equal x. The last one, it says x plus y must equal to 5. And I always say to people, whenever you get these type of lines, like it says x plus y equal 5, I could tell you that many don't know that this is really what it is saying. It is saying that you could find any two coordinates, an x1 and a y1. If you add them to give 5, you're on this line. For example, I could pick 2, 3, because 2 plus 3 is 5. That is, this is on that line, as in what? The point 2, 3 is on the line. The point 3, 2 is on the same line. The point 5, 0 is on the line. 0, 5 is on the line. I could mix this up. Negatives, I could go a negative and a positive number. As long as I check it and it come back to be 5, it is on it. Doesn't matter. You could get a very big negative and a very big positive. As long as when you do it, the result is 5, it is on the line. Right? Believe it or not. Right? So what we're suggesting here, you only need 2 of these and then draw a long line through. So I'm going to pick on this one, 5, 0 and 0, 5, because I want to draw it off my grid. So 5, 0 is right here. 0, 5 is up here. This is 0, 5. This is 5, 0. And I'm just going to connect them. And when I connect them, they will captivate everything. Believe it or not. Check it out. So I could just point it out to you. Look for yourself. Where, oh, here's the line. Look at this line. What's this point? This point is 3 meets 2, and I did not do it. I focus on these 2, and it's capturing everything. See, this is 3 meets 2, and look at this. 2 meets 3, 3 meets 2, 4 meets 1. That means 1 meets 4. It's no joke. Half meet 4.5. No joke. Look, half meet 4.5. I could tell you. This is a nice idea. A lot of people don't pick up. But when you get the equation of a line, it is telling the truth. All right. I normally just say, okay, let's relax. It's the truth. So for this, you could find x and y values that add to give 5. You just need to find 2 of them and put your little dot on your graph and draw a long line through it. It's going to catch every other point that is true for the line. So this is the line, x plus y equal 5. You hear what the line means? The x value plus the y value of a coordinate equal 5. That's what the line is saying to you. So I'm just saying from teacher to student that, hey, don't overstress when you see these. When they are this simple, all right, you could just snap your finger and get the coordinates and move. All right, sometimes you have to work it out. But when it is this simple, like x plus y give a number, you can figure out that, right, easily. All right, so those are the lines that they were asking us to draw. And you were expecting to do this and to get some marks for it. How many marks did you get? Let me look. 3 marks. The 3-mark question right there. Check it out. You'd have gotten 3 marks just to do that. Here. 3 marks to do this. 1 for each. All right, so we have that already. Let's look at the next part of the question. They're saying, on the grid, label R the region where, watch this now, they're saying, so I'm going to flip the screen now. I could flip the screen. All right. They're saying the region where x is greater or equal to a half, where the y is greater than or equal to x, and the x plus y is less than or equal to 5. These are regions, and they want us to find one region that is agreeing with all three and label that R. So let's do them one at a time. All right. If you went to the linear programming session in the week, you would have been doing something similar to this. Let's look at the first one. I'm going to look on X is greater or equal to a half. So we want to point in that direction. Let me point in the direction. X is greater. Oh, let me use, I think I have a nice arrow here. Why not? Let me use my arrow. All right, so change the color, black. So X is greater or equal to a half going that direction. See if you agree. Remember now, you're using the line where X is equal to a half, and you're pointing in the direction where X is greater than or equal to a half. So you're pointing. If you're greater than a half, obviously you're heading that way on the x-axis. So that line is suggesting that, hey, I'm heading that way. That's my inequality. Let's look at the next one. Y is greater than or equal to X. Greater than or equal to X. So let me change the marker for that. Blue. If you're greater than or equal to X, you're above the line. Look, when the line is slant, greater than mean you're above, on top of, right? There. So I'm showing you the line Y equal X, but the inequality is suggesting that we want to look at greater than or equal to, so you're above the line. All right? And then now the next one was saying X plus Y is less than or equal to 5. Let me change the color of the marker for that. So we're dealing with one now that is going to be less than. So less than is below. This one is suggesting that if you're less than, you're below the line. Below. Because if greater than goes above, less than goes below. They are saying, now look on the diagram and then use R to represent a region where all three arrows are pointed in. Take a look. It is in this triangle. R. Take a look. That region is the region where everybody is satisfied in. Every other region, 2 might be satisfied, 1 might be satisfied. But this is the region that satisfies all three inequalities. And that is why you're actually seeing the 3 arrows in that section there. There it is. And that's what they wanted from you. So sometimes it's not a big deal, but there are little ideas that you need to have up your sleeve. It's 1 mark for it, you know, because I am actually showing you what to do. A student who knows what to do is not teaching somebody in the exam. They just look at it, point the arrow, point the arrow, point the arrow, point the arrow, oh, and pick their solution region. And that is how you will be functioning. I mean, as soon as you understand fully what you're doing, we're suggesting to you that this is where the solution is. This section right here. That little triangle. All right? All right. Take our time, school. Number 5. So this one says 60. So you're told that we have, so this is so it says 60 students took an algebra test which comprised 50 multiple choice questions. The number of correct answers that each student obtained is recorded in the table. So you see the number of correct answers and how many students got them. So you read, see what you're doing easily, and then now you wanna, from this, respond to some questions. First question says what? Using the table, determining the number of students who had exactly 13 correct. Correct answers here. How many students? How many?
11.
11 students. It's straightforward, you know. I don't want you to think, you know, because it's CXC, you're going to do something fancy. It's straightforward because it has the number of students and the number of correct answers. So you look, read, oh, it's reading. Read, number of students, 13. 13 correct was 11 students. That's all. And I can't give them more than 1 mark for that. See that? 1 mark. The modal number of answers, correct answer. So you're looking for which correct answer or which question was answered correctly the most. Which question was answered correctly the most. So you look to see which one of them where you have the most students getting this. So this is the most number of students I'm seeing, but it is for question 9. Was for 9 in terms of correct. All right, so we're talking about 9 modal number of correct answer. So 9, we saw 14 students getting 9 correct. So this is a 1 mark, it's 9. It's not 14, you know. This is frequency. This is frequency. Your frequency is not your data. This is your data. And this is how frequently we saw the data. Your frequency is not a data. Number 14 is not even in it. It's just that we saw 9, 9, 9, 9, 9, 9, 9, 9. You saw 9 14 times. There's no 14. You understand what I mean? 14 is not a part of this in terms of that 14. So there's another 14 down here, which is a different thing. I'm just saying. But I'm just saying to you that, remember, your frequency is not a data. All right? So you have to be conscious of that. Next question. The median number of correct answer. Median. Remember, you know, remember, we always can find the position of the median. Remember, we said, take your frequency, add 1 to it, and check up and down the table and until you reach, for example, it is 60. As 60 students, this is your frequency. You normally add 1 to it, and then you divide everything by 2. So imagine 61 divided by 2, you're searching for 30.5. Now you're going to search where? Not the data, is the frequency column you're going to follow. You're going to add until you reach 30.5, you stop. Right? For example, 10 going up, 10 plus 9, 19. 19 plus 11, that's 30. It's not 30.5 yet. But by the time I add 2, I reach, then I stop. This is saying that 12 is a number that I need to think about. Now, that's me going up the table like that. I need to add coming down the table until I reach that number or pass it. So you start at the top coming down, 6. 6 plus 14, 20. 20 plus 2, 22. 22 plus 6, 28. 28 plus 2, 30. Still not reach 30.5. Bam, I pass it. So I have to stop. So it is saying the answer is there. Bam. So I have 2 things now in the middle. That's what this means. It means that there are 2 things in the middle, a 12 and a 13. Oh, so my median is going to be 12 and 13. 12 plus 13, and then I divide by 2. You're going to get 12.5. This is going to give you 25 over 2. And that's your median. So you have to be very careful with your responses, right? That's your median right there. So we learn how to find the position of the median right here easily. Add 1 to your frequency, divide it by 2, and then do a cumulative check up the table until it reaches that number and pass it, just stop. Go for. Come down the table next until you reach that number and pass it, you stop. Go for that number. Sometimes it is the same number. Other times it's a different number. But when it is, you add, divide by 2, and you're good. So when it's the case, when it's different, fine. We're not feeling funny. We're just going to add and divide by 2. All right. Oh, there's another question here. It says, the probability that a student chosen at random had at least 12 correct answers. At least. So you have to focus on the keyword here, at least. So it means 12 or more. You want to know how many of them got 12 or more. So you want to see at least and then interpret it as 12 or more for you to get this. So you want to go back to the table. How many persons got 12 or more as the answer? 12 or more. So then, back in the table. Here are the correct answers. 12 or more would be from here down here. So I need to check how many. 2 plus 11 plus 9. That look like 22. Plus 10, this look like 32. So that is 32 persons out of the 60. But remember, 32 is not the answer because you're answering a probability question. The probability is a proper fraction. So it is 32 out of 60. And you could break this down to whatever you want. All right, you divide this by 4, you get 8 over 15. That is correct. This is correct. 16 over 30. Still correct. Any one of those answers is fine. So remember though, that you respond to question based on what they ask. Because a lot of people would have submit 32, you're going to get it wrong because it's a 1 mark question. So it's just the dead answer they want. If this were 2 marks and you wrote 32, they give you 1. If it was a 2 mark and you write 60, you get 1. But you see, because it's a 1 mark, they are saying that we're only dealing with the correct answer only. So like when I'm marking for CXC, for a question like this, you will see this, and it means correct answer only. So if you don't write any one of these, you're wrong, right? Because there's nothing to share up. They don't give half mark. So this means correct answers only for different. So for all over the paper, they would have had certain responses that they are saying that we're only looking for the correct answer at this time. So they were looking for a correct answer here for 1 mark. All right, we're going to stop at 8 o'clock, all right? But wherever we go, we just go until we stop, all right? And you could continue working. All right, so I think we started another question? No, we're in the B part. All right, so we're still at number 5, but we're in the B part, and it says, a group of students wrote a physics examination. Each of the students achieved a grade 1, 2, 3, or 4. All right, so it's 1 to 4. The pie chart shows the results. You see in the pie chart, you're seeing the results right there, all right, as we speak. All right, so here are the questions. 39 students achieved grade 3. Determine the total number of students who wrote the exam. All right. Now, you can approach these questions a number of ways. Look at this. They are saying to us that, listen, you have 39, all right, students that actually is representing 117 degree. Yeah? So the 39 is representing 130 degree. So then, what we can do is, and they want to know how many persons would have sat this exam. You can think about it like this. I could give you a trick, or I could break this for you. You could look at it like this. 117 degrees would be 39 people or students. I could say what 1 degree is. That's 1 degree. All right. If I don't want to put it in decimal, it's fine. If I don't feel like I want to chance rounding off. All right. Because this is 0.3333333333. It goes on forever. All right. So then we're saying that 1 degree is that. Now, if 1 degree is that, right? 1 degree is 39 over that. Now, it's 360 degree make the circle. You know? Remember, 1 degree is this amount of people. Is this amount of people. 1 degree is this amount of people. So that means 360 degree, which would have been the entire thing, is going to tell you that, listen, 39 over this times 360, because this is 1. So 1 times 360, work this out, you're going to get 120 flat. Check it. 39 times 360 divided by 117, you get 120 students overall. I'm saying, just think about it. Now, this part, if you wanted to write like 0.33, it's 0.3333, because I saw that I just left the fraction. So even if you want to have 0.333 times 360, you're still going to get 120. But it's going to be near like 119 point whatever. So that is why I said to you, I love fraction, because 39 over 117 is not 0.33. It goes on to infinity. And the moment you stop it, it's like the answer becomes short. So that is why I left it as 39 over 117. To have the exact value, 120 will just jump out at you. So you could have done that. Right?
Sir,
Go ahead.
I used another method and I got
Yeah, man.
the same.
As I said to you, there are a million ways to work it out. It's up to you.
Okay.
Yeah, man, you can work out. Remember, I said this problem is mixing up a lot of things. You could, it depends on how you feel and your understanding. I'm showing you that, hey, you could do that. Another thing, if you have, we don't even need to go in that. That's like, sometimes I don't want to give too much information because some people get confused. All right? So just leave it. So whichever way you figure out to get your 120, make sure that the logic is there and you're going to get 120 now. Right? All right, so that's one approach. Now, the next question says, they're giving a ratio now. Watch this. They're saying the ratio of the number of students who achieve grade 1, 2, 3, or 4 is this. All right. So they're telling you that for grade 1, we have 2 compared to 4 compared to 3. So they're talking about grade 1, 2, and 4. There's no 3 here, right? And the student passed, no, a student passed the examination if she achieved grade 1, 2, or 3. Okay, okay. Telling that is 1, 2, and 3 passed. All right, let me see what they're saying here. The ratio of the students, number of students who achieve grade 1, 2, or 4, okay, is that. How many students passed the exam? All right. Remember, no, you want to know. So, oh, that's why they're telling you that you're going back to 1, 2, and 3 are the students who actually passed the exam. All right. 1, 2, and 3 are those who actually passed the exam. So this is the pi of here, fail, pass, pass, and pass. All right. So we have this. Remember now, we have a total of 120 students. We're dealing with 120 students overall in the exam. All right? All right. All right. So now, how are you going to use this information now? How can we use this information to guide our thinking to help us to know how many pass. We have 120. We have grade 1, grade 2, grade 4, right? So that's the ratio of the students that pass. Anybody want to suggest, how would you think that you could figure out what to do to get the number of grade 1, the number of grade 2, and the number of grade 3?
So
You
we're
can
gonna
see,
right?
you can see that this double, you know, look at this. This and this double. Say, if I know the grade 1, if I double it, I get grade 2. All right. If I double that, I'll get grade 2. So what would you do? Plus, you know, you actually know the degree. Hold on, let me show you some. I'm just giving information. If you should take out, we got 117 already. I think this is about 243 degrees. All right, I'm just writing. All right, that's the remaining part of that journey right there. All right, Jody, what were you saying? Jody? All right. All right, let's go. All right, use this. Use this. There are many approaches. So take out, check this out. If you should take out the 117, let me just tell you what to do straight. If you take out this, remember you got this already. See the question there? Look, you got, this is what you got. You got this. And everything here is one circle, and you are getting 117 out of it. So you know the remaining piece, right? Watch this. So now you have, you know that the other part was a total of 240, 243. If you take out that 117 out of the 360, all right, so let us say you have, let me put it here. Says like they do this. And this is 117. Everything else is 243. Everything else. All right, so this 243 was shared up into this. Remember, you know, look at what they gave you. They give you 1, 2, and 4, and not 3. So they pluck out. This was the grade 3 part that you know already, which is 117. So when I pluck it out, I am left with 243. And the 243, the 243 is not 243. Okay, people? All right, it looks weird. So the 243 is a total of 9 pieces. The 9 parts were shared up in proportion to 243. So you can kind of look at it like that. So then, if I should divide 243 by 9, it's going to give me what one piece is. And then from there, I think I can work. There are many ways to approach. It depends on how you're looking at. If I divide this into 9, because it's 9 parts, you know, you're going to get what? 243 divided by 9, I get 27. So that means the angles are sharing up nicely right now. Is the angles are sharing up? Look, let's go again. 117 was the angle that you got for grade 3. If you take that out, you have 243. Here, they are giving us the ratio of how the other parts were shared up. They didn't give us an angle for it, but they are saying it's in the ratio of 2 to 4 to 3. And they're talking about grade 1, grade 2, and grade 4. So grade 1, grade 2, and grade 4 was in the ratio of 2 to 4 to 3. We are saying this is 9 pieces, all right? So all the angle for this is 243. So if you divide it, you're going to get what one proportion is, 27. Now, you know what this means? It means that grade 1, all right, let's go back to the circle. So one piece is 27. This is saying this. Let me tell you what this is saying. Grade 1 would have been 2 times 27, and you're going to get about 54 degrees. Grade 2 is 4 times 27, and you're going to get 108 degrees. And this is going to be, what was it, 3? 3 times 27. Work out that for me, 327. That's about 81 degrees. Now, I'm putting them here. Add up this for me, I think it's going to be 360. Should be. Let me add it up quickly.
Yes, sir.
All right, bam. So you see how that, I don't know, but every now and then they'll give a real question that will challenge your thinking. So these are the degrees now. Now, so if I want to know, remember, this one, they really took you in a little thing for you to take out the 117 and then divide up the ratio. So they mingle ratio with this thing. But anyways, if I know that 54 degrees is for grade 1 and it's 120 people, you don't think I can know the amount of people? Yes, I can know the amount of people that pass. Watch this. What do they want? The amount of people that, where's the question? Determine the amount of, where is it?
How many students pass the exam?
How many students pass? So you're talking about grade 1, 2, and 3. So all you're going to do is to work out the angular part for grade 1, 2, and 3. So grade 1 is 54 degrees. I'm just writing this. Grade 2 was that 108 degrees. And grade 3, we got it early, 117. Add up that and represent it like 54. So this as a total is 54 plus 108 plus 117. So it is 279 degrees out of the 360. If you multiply this by 120, it's going to tell you how many pass, because it's a total of 120 that took it. You could do that, or you could do it another way, because you could find how many fail and subtract it from 120 as well. So I'm just saying, because if I use grade 4, which is the fail, and I said 81 out of 360 times 120, those are the fail, and then I subtract it from 120. We can look at it. Let's work out this. 279 divided by 360, multiply that by 120. This is 93 students. So this is saying that 93 students pass. Oh, my marker is gone, guys. Come back now. 93 pass. Because the total angle was 279 for the pass out of 360. But in the beginning, you see how this question weird? If you did not get the 120 from the beginning, you would not have been able to work out this. Because you see, you're using the 120 from a previous question when they were asking for the total. So it's weird. If you don't tie up everything, you're going to be in problem at some point. All right? Now, that's one approach. You could have done this. Let me show you. You could have got the same 93. What if you want to show the failing? Grade 4 was failing. We found out that 81 degree refers to grade 4. So this is grade 4, those who fail. Times this by 120. I believe it's about 27. See, we get 27 people. These are the failing students. So then, say if 27 fail, then those who pass will be 120 minus 27. Check it out, same answer. 93. Your approach, you're on your own with how you want to solve the problem. But at the end of the day, you're going to have to come up with 93 that pass. So it's either you're going to know the angle for those who pass and find it directly, or know the angle for those who fail, find it and subtract it from the total. But in any case, we came up with a 93 that passed. This question is what it is. So every now and then you're going to stumble on one of them that you're going to have to think about. Can you see how they mingle the ratio in this, where if you are somebody that gives up easily, even though they gave it to you straight, 1, 2, and 4, you probably walk away. But for this, it's CXC. Every now and then they want you to relax, analyze the problem, and just deal with it. But as you could see, we could come up with answers. All right. All right. I'm going to answer the last one and then we're going to stop for, that's where we're going to stop. It's now after 8. All right, let me just finalize this. It says, determine the value of the angle for the sector. Oh, we finished this already, representing grade 1, the pie chart. We found that already. Because we came up with 54 already for grade 1. Wasn't it 54? It was 54 for grade 1.
Yes, sir.
Yeah. So I noticed that 1 marker, they knew that the way in which you would do it, you're going to have to find this 54 before you even solve the problem already. So they just give you a 1 mark to write it back. All right, guys.
Can you the pie chart a second, please?
You want to go back to the pie chart?
Yes, sir.
Right there.
Thank you, sir.
Here it is. It says in this question, take pi to be 22/7. All right. So it says, the diagram below shows a rectangular tank with the base 50 cm by 40. That is used to store water. The tank is filled with water up to a depth of 15. You are seeing that. A good thing about these sort of questions is the information that you get from them. It is actually, the information you get from them is actually there. All right, so we're seeing that on screen now. All right, we're seeing that on screen right now. All right, so what we want to do is that we want to take the information and then respond to the question. All right, that's all. All right, first question, calculate the volume of water in the tank. Context, not the volume of the tank, volume of water in the tank. Words, you have to pay attention to every single letter, right, when you're doing a math exam. Now, the context here is volume of water. We got the depth of the water here. So I'll say to you, the concept of volume states that the volume of any regular shaped object or container can be found by doing this. Area of the cross section multiply by the height or the length, depending on the orientation of your object. Now, the cross section basically in this context could be the base. And when I say the base, I'm going to put some markings here. That little corner spot there, that bottom that you know, right? That's the cross section there. And so it's not given to you, but you have to start understand that, hello, if it is a rectangular prism or a rectangular thing, we know that the cross section is any uniform shape that goes through it. So it has 3 cross sections. One of them is the bottom. So you're talking about 40 multiplied by 50 and then multiply by the water, which is 15. So all we're going to do is to put those measurements together and would have gotten our mark easily. All right, this is about 30,000. Am I correct?
Yes, sir.
Yes, sir.
30,000 centimeter cube, because it's volume. So the water that is in the tank is 30,000 cm cube right there. All right, so that is based on the area of the base. and the height of the water. Let's go to the next question. Take a look at it. Now, we're told that the cylindrical container shown, right, is used to fetch more water to fill that rectangular tank. So this is another container. The container which is completely filled with water. This is the container which is completely filled with water. This is filled with water. Has a radius of 20 and a height of 21. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So basically, they are telling you that you are going to throw this in it. All of what they are saying here is that you're going to fill this. It is full. You're going to empty it in that rectangular tank. Just like that. So all I'm going to do is to try to find the volume of this. Because this volume we're dealing with. So I just need to find the volume of this. This is the volume of a cylinder. The volume of a cylinder is area of circle times height. Pi r square is circle times height. So in this context, what are we talking about? 22 over 7. Hold on, let me see what they said pi should be. 22 over 7. So pi r 20 square see there? Pi r square h. So if I want to do a little cancelling here with this 7 and this 21, I can do that. So if I want to take it out now, 70 itself 1, 70, 21, 3. So all I have to work with is 22 at the top times 20 times 20 times 3. And I am getting 26,400 centimeter cube. That is the volume of water in this. So now we're going to show that in that. So now put together what the question wants. Total volume in the rectangular tank. So we're talking about total volume in the rectangular tank. It's going to equal to the 30,000 plus this 26,400, because the question said you're going to be adding it. So you add it, you put it together. 56,400 is the total volume now that you're dealing with. Three marks there. See that? Giveaway. Now, the C part now is saying to us that, hey.
Sir.
Go ahead.
I was writing off the equation, sir.
Talk to me when you're done.
All right, sir.
All right. So next question says, show that the depth, the new depth of water in the rectangular tank is 28.2. Show. In other words, they're telling you that the new depth is 28.2, but they want you to show them. So in other words then, the water level was raised in the tank because obviously we throw water on this. So we throw some water on this. So the water level gone up. Some more water in the tank. Yeah? More water in the tank. So it gone up to a height now of this. They are telling us that it is 28.2 centimeters, but they are asking us to show that it is that. Now you're going to have to think. This is what you would call X. You don't know that. You want to prove that to them. Now, if you throw water in a tank, the idea is that the water will fill up the bottom part first. And in this context, that bottom part is your cross-section area, because even if you throw water in a cup and look, you see that the water takes the shape of the bottom of the cup. So you want to understand what is the bottom of this that you have, because it's going to be coming up by layers of the shape of the bottom. Yeah. So what do we have for the bottom? You're going to have to think this is the part that will fuel that, this section, cross-section. So we want to take a few things into consideration. One, you're taking into consideration that volume is cross-section area times height. Now, what they want you to prove is height. The context still remains. Doesn't matter what they are saying. The moment they're bringing in volume of a container and you have the measurement, it's the same thing. Remember now, you have to take into consideration that the volume now is 56,400. That's the amount of water in the tank. The cross-section area, you know it already. It's the 40 times the 50. You know it already. It's 2,000. That is that number there. And you want to multiply this by the height that we don't know yet. So we want to show them that the height is 28.2. All right. So we want to play around with those numbers so that they can see that the height is 28.2. So I'm saying to you, it's the same context. Volume, cross-section area times height. Now we need to understand the volume you have. The volume you have changed. It's 56,400. 56,400. So now, all I have to do, I'm going to have to divide. I will have to divide. Yeah? I'm going to divide by 2,000. So now if we put 56,400, yeah, divide that by 2,000, I guarantee you, you're going to see what they are saying. 28.2 centimeter is the height. So when they said show, what they are trying to do to see if you understand what you're doing. You have volume, you know the cross-section of the container by looking at it, and you have the height, which is what they are asking you to show. The context does not change. Volume is cross-section area times height. Substitute those same numbers at the right place, find your height ordinarily, and then you would have seen this coming up. Any questions surrounding any of those yet? Now let's look at the last part. The last part of the question says, the vertical height of the rectangular tank is 48. So now they're telling you that the height of the tank, this is what they're saying. This tank, they're telling you that the real height from the top to the bottom, it is 48. They're telling you that this is 48. All right? So they're telling you that the height is 48. Determining how many more cylindrical container of water must be poured into the tank, all right, for it to be completely filled. There are a number of ways to work this. I will not work it all the ways. I'm just going to solve it one way. All right, there are a number of ways that we can work that. All right, number of ways that we can work that. Now, you can find, so in other words, then there is an empty space to be filled. So you want to understand that there is an empty space to be filled. So if you're looking at the container, no. Now, they are telling us that this is 40, 50, 48. So you can use that to find the entire volume, but definitely 56 is somewhere here, like water come already up to 56. Right? Water come already up to 56 in the container. Water up to 56. So there's a little space left at the top. There is some space left at the top here. That's not yet filled up. At the top, there is some space left that we intend, that green part would have referred to an empty space that they are saying that, hey, how much of the cylindrical container should I throw in that for it to be filled? So there are two things. We already know that this part down here contains 56,400 cm cube. So what I'm going to do is to find the entire volume. When I take 56 from it, I'm going to be left with the empty space. And then I'm going to work with that. So the volume of the tank overall, the entire tank, volume of the tank is going to equal to 40 times 50 times 48. That is the entire volume of the tank itself. We're getting 96,000. This is the volume of the tank itself. Now, the water, so the empty space, so the empty space to be filled is to take out that 56,400. So that's the empty space to be filled, because we know water is in there already. So you take away that 56,400 and you realize that you're left with 39,600 cm cube. This is the empty space in green. This is the empty space in green that is left to be filled. So what you're going to do here, all right, what you're going to do here is that you want to know how many of the cylindrical container would actually work for this. How many? Now remember, the volume of the cylinder, remember that, you know? It was how much? 26,400. I want to know how much of this cylinder that I need to throw into this to reach that. How much? So I'm going to simply say the number of cylindrical container needed is going to equal to that empty space. You want to divide it by the volume of the cut. You want to know how much of it. Check out that. So it's like you're saying that is the space to be filled. Let's divide it by how much water hole in the cylinder. So you need 1.5 of that container, and it will fill the thing up. So the number of cylindrical container is 1.5. You need 1.5, and it full right up. You throw one in there, and half more, and throw in again, and it full. Let's stop there for a minute. Any questions surrounding that? All right, so we need 1.5 of that container. This is a number 7 question now. All right, so this is the pattern thing. You have to read, you don't have to read these, but you read it for information. So I'm going to read it quickly. It says the diagram below shows a sequence of figures made up of circles with dots. Each figure has one dot at the end, no, one dot at the center, and 4 dots in the circumference, okay, of each circle. All right, so you're seeing that. There's a 1 at the center and 4 at the circumference. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous, except for the first figure. And they're telling you all sorts of information. But long and short, the table is what they have to complete. First task is, so they said, complete the row in the table below for the 5th and the figure N. So that's the only thing missing. So you can, obviously you can look at the pattern. Look at the pattern. Yeah. Look at the pattern. And then, you know, you can figure out. All right. Now let's take a look. See if you can figure out those answers quickly. Look at the pattern. Look. Normally, it's because this is 1 to 5. That means if I see any pattern, I could fill out the 5th row easily. Why? Because the sequence did not break. It break after 5, so you would know what's going to come after that. But from 1 to 5, whatever you're picking up, we're adding 4, adding 4, adding 4, adding 4, 21. Because you could see the adding 4 for that. All right, so the adding 4, adding 4, adding 4, adding 4. Good to go? Everybody agree with the 21 there?
Yes, sir.
All right, so 25 is here. All right, but what about the other one now where you see it? This is technically 1 pi. Pi is 1 pi. This is 1 pi, because we know that. 1 pi, 3 pi, 5 pi, 7 pi. We assume now, based on the pattern, that this is 9 pi. Based on what they have, is a 9 pi.
Yes.
So I'm saying this row, you could observe the pattern and get it. Even though you don't know the blank one yet, because they did not break the thing before. 2, 6, 12, what is going on here? If you don't know what's going on, All right, so you're suggesting somebody saying that they add 4, they add 6, and they add 8. So I guess you're expecting them to add 10. This is 30 pi. Based on the pattern, they add 4, then they add 6, then they add 8, then they add 10. Yeah, that makes sense, right? So they're not adding the same thing, but you could see they add 4, then they add 6, then they add 8, then you say they add 10. Of course. Right, so that's a pattern you pick up. So what I'm saying, you could have gotten 3 marks without doing anything yet. You can't get 3 marks there, man. You can't get 3 marks. Now, let's go at this. For the rest of the spot now, see that you're going to think about it, or I am noticing that there is a common thing here I could figure out because they're adding 4. I see they're adding 4. The moment I'm seeing that constant thing being added, I can figure out without, you can think about it, but sometimes it does not come to you at the same time. Anybody want to figure out based on what you learn? So I'm going to stop now. Based on what you learn of how to complete this, if you realize that there is a common difference between the terms, how do you fill out this spot here? How? I'm giving everybody a minute or two. Just put it together, please. For this one,
the same formula where it's 4n plus 1. Is it the same formula?
Yeah, but I don't want to answer that, Miss Scott. I want you to pull from your memory what you think, because I want you to do that for yourself. I don't want to be a part of your decision. I don't want to be a part of the decision, you know. I don't want you to tell me what to do. I am asking you to do it now. So I'm giving you a minute to fill out this spot right there. I'm giving you a minute to fill it out. So in other words, work it out and have your answer. I won't partake. I won't tell you what to do. This one, not going to tell you what to do either. By observing these numbers, you should see what's going on and then figure out that. This one they're adding 2, you know. This one they're adding 2. They're adding 2. So this one can be done like the one where they're adding 4. Whenever you see that, you know what to do. Work it out. You learn something, do it. Let's see what you come up with. All right, let's go. All right, so if I were you and I'm seeing this, if you don't want to keep thinking, remember when there is a common difference, like you're seeing, we're adding 4, like there's a common difference. That common difference, we call it D for difference 4. The first term is called A all the time. The formula we're going to use is this. A plus n minus 1, and you put the D out there. A 4, n minus 1, D, oh, A is 5, hold on. 5, hold on. This is 5. Let me write it better. 5, right? 4, all right? So our D is 4. I had written 4 here. That was 5. Okay. A is 5. The first term, 5, right? So make sure that you have it correctly. All right. See there. D is 4, A is 5. And then all you have to do is to do your regular distribution. So you write back the 5. That becomes positive 4n. 4 times negative 1, negative 4. Simplify everything. 4n plus 1. This part is called 4n plus 1. And that's what I've been saying. Instead of doing it mentally where you're struggling to find out if they're doing what you're thinking, which is to add the common thing, just work it out quickly and move on. For this one, anybody wants to tell me what it is that they're seeing for this one? Anybody? So when you want to figure out, you have to look at these and then observe that. Look at this, observe that. Look at this, observe that. Look at this, observe that. This, that, and then when you see this, you pick up what's going here. Anybody?
N squared pi.
N squared pi. Thank you. You're seeing that they're squaring. 1 square, 1 pi. 2 square, 4 pi. 3 square, 9 pi. 4 square, 16 pi. Oh, N square with a pi behind it. So you see, whenever there's not a common difference, you can easily see the pattern, honestly. So it's either they're going to give you the pattern where you can see it, or they're going to make there is a common difference where I am saying drop the formula and you're gone. For this one, you could try to figure out what they're doing. Honestly, you can. All right, you can. All right, I'm seeing the pattern straight. But you say if you're not seeing it, like you're not seeing that it is 2n minus 1 or something like that, say you're not seeing it because you have to be guessing until you connect. What you can do is to just work it out. Look, there's a common difference of 2. So D is 2. The first term is 1. So A is 1. So what we're going to do now is to set up the same thing that I set up. All right, set up the same thing. You're going to set up A plus open bracket N minus 1 D. A is 1 plus N minus 1 D 2. Do your distribution. 2 times N, 2N. 2 times negative 1, negative 2. Simplify this, 2n minus 1. So this is actually 2n minus 1. And there's a pi behind it. So I have to put pi like that. Because you see the pi behind the number. So I can't just, look here, don't do this. Wrong. Because that is saying is negative 1 pi. Put the bracket to suggest that the 2n minus 1 is an idea. Then pi is behind that all by itself, right? Please remember this, you see, the reason why I'm giving you this is I find out that this is the best thing that I could do for you with this table. The moment you see that there is a common difference and you use this, you just get it. And I would advise you to fill out this part first. Go down the bottom and fill out those first so that you can navigate the rest of the table. Now, let's observe this now. You do realize that there's not any common difference here between the numbers. All right, you add this, you add that, different thing you're adding. So you can't approach it like the formula over there, because the formula is when there is a common difference between the terms. What you can do though is to observe this. Take a quick look. I'm seeing 1 here, and then there's a 2 in front of pi. Whenever I see 2, I'm seeing 3, I'm actually seeing 6, but what I'm thinking of is some multiplication is going on, but by what? Because look, if I say 1 times 2, okay. And if I say 2 times 3, I see 6. And if I say 3 times 4, I see 12. Something is going on. And if I see 4 times 5, I see 20. And if I see 5 times 6, I get 30. So I'm like, okay, what is going on? Anybody want to suggest when you reach n, what are you going to say? when you reach n? Anybody? What do you notice here going on? Look at the relationship between the numbers. What's a general conclusion you can draw? What general conclusion you can draw now about these numbers that I added here compared to the numbers beside them? Anybody? Anybody quickly?
N times 7, sir.
Oh no, I'm not asking you about the answer. No. Listen to my question. I am saying, do you see any general idea about the number that I am immediately working at? I place the numbers beside here so that you could see that 1 times 2 is 2, 2 times 3 give you 6, 3 times 4 give you 12. I was the one that saw that. But what I want you to do now is to use what I saw to figure out what you think should go beside this. As in, n what with pi? Anybody?
N times n plus 1.
Huh?
N times n plus 1.
Exactly. It's 1 more than the number. Look. 1 multiplied by 1 more than 1, which is 2. 2 multiplied by 1 more than 2, which is 3. 3 multiplied by 1 more than 3, which is 4. You're on your own with this, there's no teaching of this really. In reality, there is no teaching. The only thing that is there to be taught, and that's what I did with the formula. Outside of the formula, there's nothing else anybody can help you with. You're on your own. So the truth is, this is the only thing that I could have given you over here. But that I could say as a teacher to student, whenever you see that, use it. Everything else you're on your own in terms of you have to see it. So you would have to look and figure out how this relate to that. So you are on your own. And when we realize that they're multiplying by 1 more than themselves, and you reach n. 1 more than n is just n plus 1. We want you to see that and embrace it and move on. So the table completed 7 marks. Obviously, there are other questions down here now. There it is. Determine the value of n when the number of dots in figure n is 541. So look, read. Determine the value of n when the number of dots. So you're focusing on the number of dots. Go back to your table. The number of dots is what column? This column. Number of dots. This. This represents the number of dots. 4n plus 1 represent this column. So what you're gonna do at this question is to know that the column that you're dealing with, 4n plus 1 represented. And they are saying find n if 4n plus 1 is equal to 505. That's what they're saying. Determine the value of n when the number of dots in n figure is this. In other words, they are saying, what is the n value here? What number would have been here such that 541 there? That's what they're asking. So we are saying that, don't worry yourself. Don't worry yourself. Let the general formula equal to it. So you have to understand, read, go back to the table, make sure that you're picking up the right formula. Solve, we're going to solve. We're going -1, -1. Divide by 4, divide by 4. So you're doing regular math all the way. Think about what you're doing. This is about 135. N is 135. So you're so far that gone. So anybody who decided to keep writing down like adding 4, may the Lord help you by the time you reach to that number, exam finish. So you want to be able to just jump based on context. It doesn't matter what they tell me. From them, give me the number of dots and they tell me the number, I take this formula and solve for it. Trust me, I could do that all day. All right. There's another question now for 1 mark. Write down in terms of P. So context. Write down in terms of P and pi, the area of the largest circle, right, in figure 3P. Come back to your concept. Something up here speak about area. See it here? So it's not anything while they're talking to you, they're talking to you about this. So whenever you read those added questions, come back to your columns. I'm wondering what they're talking about. See there? Area of outer largest circle. So we're dealing with the largest circle right there. Now, they are saying that the figure is 3P. Remember? No? All right. Is equal to 3P. The column, see the column here. See the column here. This is the column we're dealing with. So it is n squared with pi behind it. See there? So they're talking about the outer shell, this one. All right. So n squared with pi. Let me go back down here. So the formula for that is n squared, right? Pi. Take one more look at it. All right, so it's n squared pi. No problem. So then n is 3p, so you're going to put that. This is n. That is n squared, and put the pi behind it. That's all they want. It's just a substitution, you know. So this becomes 9p squared pi. That's why it's one digger mark, because they want to know if you understand just the substitute, you know. Did I tell you? 3p.
Excuse me, sir.
Go ahead.
Sir, would you still have to keep the square on the 9p?
The square is not on the 9. The square is on the p, no, because I did say 9. I said 3 is 9 already. So if you want to work it out, you'd have 3 squared, p squared, pi. But 3 squared gives 9. P squared is just p squared. It's not a number. And then pi behind it. Are you okay?
Yes, sir.
All right, good. So you did square the 3, but because it's a number, it will give you back a number. All right, and that's the beauty with numbers. One number square turns into a new number. All right, and you're gone. All right, guys, let's keep working. All right, so we're at the big topic here, algebra relation function graph. So the question says the straight line graph of x is equal to 5 minus 3y intersects the x-axis at P and the y-axis at Q. Remember, you know, you have to read your context. Let's go again. The straight line graph of x equal to 5 minus 3y intersects the x-axis at P and the y-axis at Q. Fine. Determine the coordinates of P and Q. Now, what are they getting at here is that you want to understand that any line that crosses x and y-axis, this is x, this is y. This is my line. Now, when that happens, we want to understand what goes on there and what goes on there. And let me tell you what you mean. You will understand that this is where 0 meets 0, right there. Right there in that corner is when 0. All right, my board is not responding. Give me a minute. It's going to come back in a minute. All right, I think it's back. All right, so I was saying that that spot there is where 0 meets 0. Now, the truth is, you know, when you intercept the y-axis, x is 0. It's 0 with some number. And when you intercept the x-axis, the y value is 0. That's what you want to know. So you probably need to note that though. When you intercept the x-axis, y has a 0 as a coordinate. And when you intercept the y-axis, x has a 0. Watch this. It means then I can fill out some of this already. Interception of x-axis is p. That means this is 0 there. If you intercept the y-axis at q, that means 0 is 0. Because the moment you intercept y and x, understand yourself. If you intercept x-axis, the y value is 0. You intercept y-axis, x value is 0. That is what you're going to use to solve the problem. So first, I'm going to find p. So if I want to find p, p is x-intercept. It means y equals 0. Always. Therefore, I'm going to take this formula and because I want to know the x value when y is 0, I'm going to put 0 where y is. X is equal to 5 minus 0, which is 5. P is 5, 0. Everybody can say that? For Q, I'm finding y-intercept. Y-intercept is x equals 0. I have the equation of the line. X is 0. So I substitute x where 0 is. And you solve. So I could get the 3y on the other side. It's going to be positive 3y over here equal 5. Divide by 3, divide by 3. So y is equal to 5 over 3. There it is. So you would have found your x and y-intercept right there. Take a look, see if you're okay. Tell me if you're all right, please.
Okay, sir.
All right, so we have our intercepts there. Now, next question says calculate the length of PQ, giving your answer to 2 decimal places. You notice that this is a number 8 question and they're giving coordinate geometry because number 8 says algebra, function, relation, and graph. So you see how the CXC thing weird? Because graph is here, CXC could put any graph in. Even statistics graph can come in. Any graph. So at number 8, it's going to be an algebra question, functional relation question, or any graph. Any graph. You understand? And that is, and this is 2021. This is very recent. It's not like this is like a long time. No, this is current. You understand? So we're suggesting that open your minds and be ready. We're doing the length of the line, PQ, and they want it to 2 decimal places. So like when you're normally in class and people say, sir, should I run it after this? At CXC will want, they'll tell you what they want when they are ready. Now, PQ, the coordinate for P is 5, 0. The coordinate for P is 0, 5 thirds. Now, let's take a quick look at what we're dealing with. Now, this is X. This is Y. So X1, Y1, X2, Y2. because I'm going to find the length of the line. It's Pythagoras theory you use. So you're talking about the length of PQ, and it's going to equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So under here, you're talking about 0 minus 5 squared plus 5/3 minus 0 squared. This becomes, so what we have there, but since it's a DP, we could work this as 5/3 is 1.67, and let me just 5 divided by 3, yeah, 1.67. So we could put 1.67 here. Since they said they want 2dp2, we could put 1.67 there, right? So you're talking about squaring the -5. Please put this in a bracket. 1.67 squared, put it in a bracket. All right. Why am I forcing that? It's because you want your calculator to pick up the wrong thing. Every now and then it happens. So anyways, we're going. 25 plus, anybody? Add that to 25. So we're taking the square root of 27.7889. Take the square root of that. You get about 5.27 there about. And I'm getting 5.27 units.
Sir, I got,
go ahead, I'm listening to you.
sir, I got 5.28.
How did you get 5.28? Go ahead. What are the
Sir,
numbers that
I
you did
found the
differently?
square root of 27.7889.
Yeah, but that's what I did. It's the same thing I did on my calculator. So, oh, you get something different. Check it out, man. 27 point.
Sir, it was in the wrong mode. Sorry.
Oh, because I'm saying that is that exact number that you see on the screen I use. And I'm getting this answer here. So you're good now?
Yes, sir.
All right, good. All right, good. At least you're checking. Very good. Now, another question now. It says R is the midpoint. Remember, we do all of these, you know. R is the midpoint, and they wanted to tell the coordinate. Watch, I'm going to write back my P. What was P again, EJ? What was P again? Remember? 50. Guys, go ahead and find your midpoint. If you're going to find midpoint, you still do the same principle, man. Label up your points. X1, Y1, X2, Y2. Your midpoint is a coordinates. So the midpoint is going to be X1 plus X2 all over 2. Y1 plus Y2 all over 2. The coordinate goes in that bracket. So you put that together. That is what you want to put together. Right? So let's go ahead and sort that out. So then X1 is 5 plus X2 0 over 2. Y1 is 0 plus 5 over 3, and then over 2. All right? And you want to just finalize the thing. Now, for this part, you'll add 5 over 2 there. That's fine. You could leave that as a final answer. All right? But let us look at this part, what it really means. So I'm just going to put it at the side so you could put the other one here. This other one here, you know, this is what it is saying. So it looks weird, but it's fine. It is actually 5 over 3. And so you want to work out the value, I'm just going to just take my time to show you. It means divide by 2 over 1. All right, makes sense? Because 2 means 2 over 1, and the long line means divide. And I'm only doing this because there's a fraction on top there, and some of you might feel uncomfortable if you don't know the tricks. But fine, you could set it up like this. So it is still 5 over 3 times 1 over 2, and you could say that this is 5 over 6. So you put your 5 over 6 there, and you're good. So at times you might have to deviate, take some time to figure out something and come back. This is regular division of fractions. Execute it the proper way and move on. Any question on this? Are we okay? Everybody good?
Yes, sir.
Yes, sir.
All right. Let's look at that now. It says the function f and g are defined as follows. All right? F of x. Remember, I said to you, even when you see they set it up like that, read it the same way. F of x, that's what it means. So they could write it like that. F of x is equal to 5 minus x. G of x is equal to x squared minus 2x minus 1. Fine. Question. The graphs of the f of x and the g of x meet at m and n. Determine the coordinates of the points of m and n. They are telling you that they meet, you know. But when they meet, when these things meet in math, it's equality it means. When two lines meet, they're telling you that they're equal. If two functions meet at that point, they're equal. So all the question is saying is this. The f of f function is equal to 5 minus x. The g of x function is equal to x squared minus 2x minus 1. Now they're saying, so don't stress the graph of these functions. They're saying there is a graph for them, they meet. So if you want me to show you what they're saying is this, let's go for it, because we can. All right. So if we can go for stuff, we can go for it. You can have a good look at ideas. GeoGebra, here it is. All right. Could somebody tell me 5x minus that? All right. Let me see if this is coming up. Give me 1, 2. Really? All right. Let me go for it one more time. One more spin. All right. I think I know what's the problem. Let me use this. Give me 1 second there. GeoGebra. I think it might work in this. Okay. Something is wrong with this side. Last time. Let me look at my internet. EJ, internet gone? You know, some of my phone may I use and I realize. So maybe I not cause it's on my phone me there all the time. See there? On the phone me there. Never realize. I'm a data me I use, brother. All right, let's go. I'm going to drop in the function. All right, so we're saying that I'm going to put y. Y is equal to is it 5 minus x? Was that it? 5 minus x?
Yes, sir.
All right, that's 1. So that's the another one was x squared. Talk to me.
X square minus 2x minus 1.
All right. So I want you to see. I'm just showing you. I never had to, but we're in class. No problem. So what they're suggesting to you is, see them here? They are suggesting that, hello, the two things meet. They call that M and they call that N. See there? Anyways, those are the solutions that we're about to get. You see them? Negative 2, 7, 3, 2. See them? That's where they meet.
Yes, sir.
So that all they're saying is the two functions, the f here up here, so the g function here, they cross at points. So I'm saying to you, whenever they cross, they are equal to each other. Another thing I could say to you is this. So I'm going to use it as a teachable moment. Let me mark up this for a minute for you. Watch. You see the line that you're looking at? Let me see if I could change the color of this line. Color. Where do I get the color? Here? All right, not seeing color. All right. Do I see color here? All right. All right, let's leave that. All right. So I'm suggesting that these lines that you're looking at two graphs, right? One of them is a curve and one is a straight line. Do you know that there are some points that the curve is greater than the straight line, and there are times when the straight line is greater? You see, anyone is below at any point, as long as you're underneath it, you're lower. That means you're lesser than it. In other words, the curve is less than the straight line here. Tell me if you agree. It is underneath the straight line where I'm marking the curve underneath the straight line. True or false? Yeah, man, it's underneath it. And guess now the contrary to this now. Look over here now. Would you agree that the curve is greater than the straight line in this section because the curve is on top of it? True or false?
True, sir.
On top of it. So you know what that means? There is a time when none of them is greater, and that time is when they are crossing path. Because as long as you have somebody cross path, you know it's only equal, right? So 1. Yeah, man, you can't hype up on somebody and then you and them are got the same place. We are saying that the fact that you and them buck up at the same place, when they're on the same level. Yeah, man. See there? So you see, at that point, we are certain these two things are equal. So if you're going to solve any problem, when they're asking about determining the coordinates of the points, they are saying to the graph, meet. You see, when they meet, they are equal. They're not telling you, but that's what is the truth. So when they meet, meeting means that they are equal. So at M and N. Let's go for M and N. Right? All right, let's go. Now, you're going to equate 5 minus x. Oh, I feel like I want to do this on the other page. Do I have space here? Maybe, maybe not. All right, let's go. 5 minus x, let me give myself enough space. Let me put it up here. 5 minus x is equal to x squared minus 2x minus 1. I'm saying to you, whenever they intersect or cross path, they are equal. So you can find that place now. So then, what you're going to do, you're going to look at your eye and realize that this is a quadratic you're dealing with. You have to see that. So you're going to get everything on one side, let it equal to 0. So imagine that we're doing that. So watch the movements now. X squared, there's a minus 2x. This is going to come on the other side. It's negative, so it's going to be a positive x on the other side. There is a minus 1 there already. This 5 is a positive 5, so it's going to be a negative when you reach over there. And everything will go equal to 0. You can put the 0 at the back or the front. Simplify this. X squared plus x minus 6 equals 0. That's where we are. So now you put it together, you realize it's a quadratic, you're going to solve it. All right? So in solving this now, you can factorize this, you know. So the numbers I'm looking for to get 6 would be a positive 3x and a negative 2x. So it's not every time I'm going to sit down and say 1 times negative 6 is negative 6. 1 times 6 class, 2 times 3. That's what I'm saying when I see this. So it's a 2 and the 3 can give a 1. You understand? AC is negative, 1 is positive, 1 is negative. Let the bigger one take the sign of B. B is positive 1.
Sir,
All of that? Yes.
how is that positive 1?
How is what positive 1?
The X you just,
Oh, it is actually negative 1. All right? So fix them. So this is a negative 1 based on 2s. That means this is going to be negative and that's positive. So what we're saying is when you're ready to factorize your thing, right? And you grab your thing, you do it quickly, do what you have to do, you take them. So it's a 3 and a 2. Since the B is negative, the 3 is going to be the negative 1, the 2 is going to be positive. You plug them in. It is still equal to 0. You're solving, do what you have to do. So let's go through. X minus 3, positive 2, x minus 3, 0. Finalize x minus 3, x plus 2, 0. From here, either x minus 3 is a 0 or x plus 2 equals 0. From this, x is equal to 3, x is equal to negative 2. So you have the two x values. See it here? Everybody see the negative 2 and the positive 3 over here? No joke. See them here over the left side? Look good. Negative 2, positive 3. So what we're going to do now is to find out the y values for those. Each x value has its own y value. It's a coordinate. So we're going to find out what's the y value for that, then find out what's the y value for that. We're going to draw a 2 line here, split it into 2, then rub off this over here. Use a different color marker now, maybe blue, purple. So when x is 3, remember, you want to know when x is 3, what is y? You can use any one of these. Use the easiest one. Y is equal to 5 minus x. Y is equal to 5 minus 3, 2. Y is equal to 2. X is equal to 3. Look over here. You'll see one of that. That's 3 meets 2. All right. So as the coordinate, you could see 3, 2. Because they did say the coordinate. Now, the next one, though, you want to look at is when x equal to the next number, which is negative 2, y is still equal to 5 minus x, which is 5 minus x, but x is negative 2. 5 plus 2, y is 7. So you're talking about negative 2 linking with positive 7. So if this is m, then that is n. Those are the coordinates. Look for yourself. Remember, we knew what we're going to get to. Look at it again. See the negative 2 and positive 7 there. We work them out. See it here?
Sir,
3, yes.
may I ask, why didn't you use the other function?
Oh, because you can use both, but use the easiest one.
Okay, you don't so fine.
Yeah, man, use the easiest one all the time. So you can use this or you can use this, but I would not waste my time to do all that work when I can just get away with that. And I'm going to get the exact answer. If you try to get the same answer, but it's a waste of energy and time. So always, I understand this. When you're doing a system, and this is what we call like a system, two things clashing. At the end of the day, when you're going to substitute, look for the easiest one for you, the easiest, always.
Thank you.
All right, good. All right, so there it is. Section 2 of the paper we have to know. This is the so-called difficult aspect of the paper. The concepts and the ideas, you have to own. You have to start owning your ideas now, though. You have to start owning your ideas. All right, you put together your talent, get your stuff, go for it. Make effort to go back through the recording, guys. The questions, powerful questions. But this is it. This is the examiner. You're not getting an order. Sit here. You're not getting an order. So it's not like you're going to go in there and see something else. Ta-da! Anybody remember what we did the last time? Here it is. I don't know if this was a question that we took. Maybe. I don't know. But here is this was one of the questions that I was saying that, guys, we haven't done this yet, but I'm happy that we actually took some time out to do it. Where literally we finish every single aspect of the syllabus. I could tell you, you will not see one question that we haven't done the topic in class in our time. All right, so it's up to you now to do what you have to do. So let us go through. I think I might have done the same question.
Sir, this is the same question.
This is the question because this is the question that I grabbed to throw in the class because I was looking for the most recent one to show you that, hey, but I'm still going to do it, you know, because I wouldn't know that I took it from this paper. This is 2021. That's how it goes. All right, it says Monty is cycling at 12 meters per second. After 4.5 seconds, he started to decelerate, and after a further 2.5, he stops. The speed time graph shows that. You're seeing that. Question, calculate the constant deceleration. Deceleration. Deceleration is negative acceleration. This is negative acceleration. All right. The fact that they use the word deceleration, you're not going to use the negative aspect of the number. So here is the deal. Let us write down what this is. So I could write deceleration here. Or I could, you know what, I'm going to write acceleration. And then we write the thing in the end. So this is acceleration that I'm going to write. So it is change in speed over change in time. Change in the speed. And the reason why I'm using speed is speed and this. If it was velocity, I'll put velocity. So the speed was coming from 12 and it ended at 0, you know, because this is 0, so 0 there. So 12 up here. So you're coming from 12 to 0. So the change in speed is that you're going to have 0 minus 12. You have to put the final one first. So the final result minus the initial, that is why we're going to put 7.5 minus 4.5 here. 7 minus 4.5 should say. Okay, you have to put the final time and put the initial time when the journey started. Right there was 4.5. So now keep working. You will have negative 12 over 2.5. So work out that. We have negative 4.8 meters per second square. But because the questions use the word deceleration, you have to remember when you use the term deceleration, you have to take the negative of your answer. So it's going to be 4.8 meters per second square. All right. The moment you use the term decelerate, you can't put negative on it anymore. I'm going to switch on this. All right. Monty, average speed over the 7 seconds. Average speed. Average speed. So you're going to have to write down what average speed is first. Average speed is total distance over total time. Now I know the total time is 7. I don't know the total distance, and that's the issue. We have to work out the distance and come back. Distance. Distance can be calculated by the area of the shape you see, the area under the curve, we call it. All of that. So remember now, you know, total distance over total time. We have the total time, which is 7. I need the total distance. So I'm going to work out the area of the trapezium and go. Now, this distance here from here to here is 4.5. And then this length of side down here, you saw it, is 7. And the height that you have to deal with is 12. The area of this shape is a trapezium. It's going to equal to A plus B over 2 times height. A plus B refers to the sum of the parallel sides. Here they are. 1, 2. Parallel sides. H is the height. Here it is. So we're talking about 4.5 plus 7 all over 2. And you want to multiply that by 12. So you have to take your time with your calculator. Work it out and let us see what we have. What you get? All right, 4.5 plus 7 divided by 2 times 12, 196. We get 69. 69, I got 96. Eh? So we get 96. Yeah, man, your calculator you now use right. 7 divided by 2, we add 1. I made mistake. You hear me? Oi, don't make that mistake there. Don't make this mistake. Look at this. When you're putting stuff in your calculator, don't do this. Your calculator is a machine. If you put this on your calculator, you're gonna get the wrong answer. If you do this, if you do that, you're gonna get 96, which is wrong. The only reason why it's wrong is because you don't use a bracket or anything to tell the calculator specific instruction. Now, the calculator will do order of operation on you, and you never ask for that. So you see, if you want the calculator to do what you have to remember that the sum of this must be divided by 2. So you have to put a bracket around your 4.5 and your 7. Then you can touch division and then multiply by 12 to get the right answer. All right. So anybody who got 69, you did not do this. You have to do it on your calculator. You get it? As long as you put more than one operation without any bracket or anything, the calculator will do BAMDAS. BAMDAS was built into the calculator. So you have to make sure that you're doing the right thing. It's always going to work, the order of operation, which will flop what you're doing. All right, so 69 is the number, and that is the distance. So we can put 69 here. And we're done. 69 divided by 7, 9.5. No, 9.8. 9.86 meters per second. Average speed. Everybody tell me if we're good with that. Yeah, watch yourself, boy. All right. All right, let's continue working. Next question. All right. You see, back to this. If you never remember, say you're doing this. Remember the instruction that you got, that the acceleration is a gradient. Please remember that. Your acceleration is always a gradient. So even if for some reason you're stuck, try to find the gradient of from this point to that point, and you get this still. You still get that. The gradient. And when I say the gradient, you understand, know what you're picking up. See, you're picking up 4.5 with 12. And then you're picking up 7 with 0 here. Label them. This is 7 and 0. And right here, so it's 4.5, 12. Pick up them X1, still work at the gradient. Honestly. See there, you pick them up. Say you pick them up 4.5 with a 12 is that point. And 7 with a 0 is the other point. We're talking about, I'm just saying to you, like, one time I'm trying to see if I can give you everything that can work. So let me rub it off for a moment. All right. We're not in any rush. So this is this to here. That's a deceleration. This is the line. So the acceleration or deceleration is the gradient. So I'm suggesting that right here is where 4.5 meets 12. And down here is where 7 meets 0. You still can say x1, y1, x2, y2. The numbers you see I get will be the same. All right, check it out. All right, y2 minus y1. Look, 0 minus 12, see there? x2, 7, minus x1, 4.5. You see that? Same. Same concept, same idea. All right? So if you don't remember to work out it normally, use the gradient and it still work out for you just the same. Up to you. But remember that if you have speed or velocity time graph, you're dealing with the acceleration is like the gradient. It is the gradient. All right. And if you have distance against time, the graph you're seeing, which is the gradient, is speed. So you could put those together. All right, running on, number 9. Number 9 says in the diagram below, A, B, C, D, A, B, C, and D are points on the circumference. All right. Calculate, with the center O. So they're giving AOC and DOD are diameter. So we get some diameter. All right. And they're telling us that AB and DC are parallel. All right. So you see, when things are parallel, I get extra energy now. Maybe co-interior can work. Z angle can work. I don't know, depending on what the question will be about. So let us see. It says, state the reason why angle ABC is 90. They're already telling you that ABC is 90. You know? They're telling you that ABC is 90. They're telling us. And all they want is the reason. EJ, what's the reason? What's the reason? Eh? Huh? Look at it, man. You're not going to know without looking. You have to look and think. They're telling you that ABC is 90. You're not going to your handout. Guys, remember we send the handout here. ABC is 90. Why?
Semicircle.
Oh, a semicircle equals to 90 degrees.
Easily. Angle in a semicircle is 90. So angle in a semicircle is 90. That is the reason why it's 90. So you see, they ask the question, they're telling you no one is asking for a reason. Don't mess up those easy things. Determine the value of each of the following angles. Show detailed working where necessary and give a reason, a singular, to support your answer. So the first one is BAC, back. So let's go for that. BAC. Go in the wrong place. BAC, back. BAC, back. Right here. Right here. All right. Now, they want you to find that. BAC. Let me look what they want. All right. Think about it. Now you're going to have to put together the ideas. There are a number of ways you can approach the question. I am saying...
Could you use algebra?
And could you use? You have to use it because algebra is in the question, don't it? Yes. Algebra is in it because so you have to, but how are you going to do it? Because you're going to have to look and understand that, listen, this triangle, like every other triangle, the total interior angle is 180. I know that this angle up here is 90 already. So it simply means that the other two angles must add to give you 90 as well. Because this angle plus this angle must be 90. Because 90 and 90 is 180. So you want to take that and you want to run with it. So you want to say 2p plus 3p equal 90. Tell me if you don't agree with that.
Yes, sir.
Those two
Yes,
angles
sir.
must add to 90, man. Because everything must come to 180 and we know 90 out of it. Take it out. We're left with 90. Another person in the class might say 2p plus 3p plus 90 equal 180. That's another approach. So when they set it up now, they're going to get 5p equal to 180 minus 90. So you're going to say 5p going to come back to the 90, which is what we have here. 5p is 90. So you see that? Two different approach, but at the end of the day, you end up at the exact spot. Let's divide both sides by 5. Divide by 5. What do we have? P is equal to what? 18?
Yes,
Yeah.
sir.
90
Yes,
divided by 5 is 18. P is equal to 18. That means the angle now, BAC, which is 2P, means 2 times 18, which is 36 degrees. See what I go now? So yes,
Excuse me, sir.
go ahead.
Sir, where did you get 18 from?
All right, let me ask you some question first. Do you agree with this statement?
Yes, sir.
All right. So you agree that 2p plus 3p is 5p
Yes, sir.
and 5p equal 90. But I don't want 5p. I need to know what p is. So you divide both sides by 5, right?
Yes, sir.
So 90 divided by 5 gives you,
18.
put it on your calculator.
Yes, sir.
So that is how now. All right. So that is how we get p to the 18. But that wouldn't solve the problem because the angle that they asked us for is 2p. So we went a step further now. Finding this angle, it's 2p, and 2 times 18 is 36. Now, that working would have been, at the appropriate place. I never wanted to, let me rush off this, 36. What's the reason that we could use? There are many things they could do there. I would just say that this is what helped us. Total interior angle of a triangle is 180 degrees. That's what we use. Can we take the 90 from it and work the other 90? All right. Now they want angle Q. Let's go back to it. Angle Q. Take a good look at it. Anybody want to tell me what angle Q is?
Sir, 36.
Exactly. And what's your reason?
Sir, it's a Z angle and the type of triangle, so both angles would be equal.
When you said Z angle, I'm trying to understand. Because this angle is Z angle to this, and there's nothing up there yet. So you can't use that to get nothing. So what really did you use to get the 36 right now?
Sir, angles on the same segment are equal.
That's it. Agree, sir? Because you wouldn't know the Z angle, not use it. Because we don't have anything up here we don't have this angle, which is the Z angle for that. So I'm saying what they just said is the reason to get the 36 now. This 36 is this 36 because angle in the same segment are equal. Now, maybe sometimes it's the shape of the diagram that allows people not to feel that way. So I'm going to turn it around for you and just for you to feel a little bit better. But in the exam, remember CXC not going to set it up for you to feel good. They don't care. But I'm just going to let you feel a little bit better when I rotate it for you. Watch. I think I could rotate it right here. Ready? If I did this, maybe if I did this for you, let me carry it to my board. I'm not getting a good grip. If I bring it here, all right. All right. What I was saying is, I think I twist up the diagram up there. If you rotate it and you turn it to yourself like this, maybe you feel better. Because in class, you might see it from this angle. You understand? To see the same segment like when we did this for you. And we did this, we did that. And most times you might see it from this angle. And you're saying this is this same segment because the segment is down here. And the other segment now is the unshaded one where they go to the circumference. So it's like this is the regular, and the other segment go to the circumference. These angles are the same. Same segment is what call those to be the same. All right, it's the same segment. Answer that. So this now you would have just said this is 36 degrees, and you say angle in the same segment are equal. You have to study them if you know that. Angle in the same segment are equal. You have to look at it, you have to study them to know. The next one says calculate the value of angle R. Go back and look at it, the value of angle R. There it is. The value of angle R. There are a number of ways you can find it. Anybody want to tell me what angle R is?
This is 36 as well, sir.
Exactly.
Because the two vertices are equal. It's an isosceles triangle.
All right. Very good. That's one of the way you could say, so this is an isosceles. Huh?
Yeah, sir, that's the basis that I was going off of before when I said I used the Z angle to find it.
Okay. Okay, you could use Z angle here this time too, because this angle is this angle by the Z angle. Back way Z. See the Z here? That angle is, you see that? So you see, it's how many rules giving us 36? This is 36 by isosceles if you want. And another person can see the Z angle and get it. All right? So yes, isosceles could work. Okay. And you could find the Z angle as well. So any one of them you want to find, angle R is 36. So angle R is 36. And you could say, you could tell them that here is the isosceles triangle that I use. Or we could have said it's the alternate angle. So when it says Z angle, remember it's alternate angle is the property. Alternate angles are equal. All right. So that's circle theorem. All right. Next question. From arbor H, the bearing of two buoys S and Q are 185 and 311 respectively.
Can you walk up, please? Finish, sir.
Okay. All right. All right. So the next question says, from arbor H, the bearing of two boys, S and Q, are 185 and 311 respectively. Q is 54.5.4 kilometers from H, while S is 3.5 kilometers from H. On the diagram below, which shows the sketch of this information, insert the value of the mark angle. All right. So please put in this value here. The mark angle is QHS, which is right here. Anybody want to tell me what the value of that is? I think it's supposed to be a 1 mark. Oh yeah, it's 1 mark up there. Anybody want to tell me what the value for that? Anybody? How would you find it? Based on the information you got, let me highlight your information. Look, they give you the bearing. They give you the bearing of H to S, and they give the bearings also to Q. So in other words, you get this bearing too, you get H, which is 185, H to S, and you get the one that goes all the way to Q, which is 311. So you get the one in red, you get that. Anybody wants to tell what you do? Going once, going twice.
Subtract.
When you get two bearings that overlap, man, and then you see that they're asking for, a part of it, always subtract. Always. Every time. So for this answer here, so the angle $126. Because the idea is that it's like they would give you all of this angle.
Say I can go pick up, please.
It's like they give you all of that. And then after that, they gave you part of it. You know what I mean? So it's like they give you everything, which is 310, and then the one in blue is 185. And then they're asking you for the little leftover here. All you have to do is subtract the two. Because remember, the 311 passed the 185 and gone. And what they want is where the 185 stop. So following this 311, you're going to stop at 185, and they're asking you for the remainder. You subtract. All right. Calculate QS, the distance between the two. So I'm going to do QS right here. So the question wants us to find QS, which is this right there. So what we're going to do is put on the labeling for the sides. There are some sides that we got that we haven't put on. Q is 5.4 from H. S is 3.5. So then you can find QS by using the cosine rule. Run out of space. All right, I don't have enough space there. Let me not do it here. All right, let me blow up at the diagram. I probably could do it below it. All right, so put together the numbers. All right, we're gonna take the square root of that number. All right, tell me if you're getting 7.98.
Yes, sir.
Huh? All right, so it does work. So the next question is calculate the bearing of S. Calculate the bearing of S from Q. Look at it. Bearing of S from Q. So what you want to find is all of this. Look. All right, so you want to find that. Now you're going to have to take a look. You want to find that this is not. Now remember though, if I take 311 from 360, I'm going to get 49 in that little corner. So I'm going to say 360 minus 311. It gives me 49 in that corner. Which means that I can use co-interior to find the green angle there. And then I'm going to do something else to find the piece in the triangle. But I'm going to color code them. So the green and then this pink piece is in the triangle. So if I find the piece in the triangle and add it to the green, I'll get the bearing. Right now, I'm able to find the green angle because I could use co-interior and said 180 minus the 49. Because the angle 49 and the green, they are co-interior. All right, you get what? 131. This angle up here is 131 in green. So all I want now is the angle in the triangle to add to the 131, and I'll get the bearing from Q coming all the way to S. Q to S. So it's the bearing of S from Q. So now let's go for the angle in the triangle. Remember now, I could take off these because we're not using it anymore. Remember, when you're finding sides and angles, what you want to do is to take a look. All right, you have to look at the triangle. Look if you have opposite sides linking to the angles. They will give you one, you will have one pair, for example. I have one pair here. And I have the 3.5 and I want this right here. So I'm going to use A over sine A, B over sine B. So the sine rule now will help me because I can say 7.98 over the sine of 126. And that is equal to 3.5 over the sine of this angle that I want. So from here, we can do the maths, whichever way you're comfortable. You can do cross multiplication, those numbers. From bottom right, top left, say just cross multiply. So you're gonna have 7.98 times sine of that, which is equal to 3.5 times the sine of 126. Then you divide both sides by so the sine of the angle is actually that. Find out that value first. 3.5 times the sine of 126. Divide that by 7.98. Write this up to about 4 dp. Then you take the inverse sine of that number and the angle will come out. We get 20.8 degrees. This little piece down here in black is 20.8. Now the bearing now of S from Q is 131 plus 20.8. 151.8 degrees. That's the bearing. All right, well, one more question to do. We're going to do it before we come off. Crunch time, I know. So we're just going to finish. One more to do and then we go. All right, let's go. All right, number 10, as you could see, vector matrices. So let's go. It says here, given the matrix W, all right, so given the matrix W is 3, 6, negative 2, 5, determine the 2 by 2 matrix such that when you add W and L, you get 0, 0. I think I'll give you a question like that sometime. So this is W. So they are asking this matrix plus some matrix called L you should get 0, 0 at these spots. What are the numbers we're going to be putting at these spots? So you want to think, the fact that I want to get zeros, it means that I need to put the opposite of the numbers. So 3 links with -3, +6 link with -6, -2 with +2, +5 with -5. I'm just going to put the opposite of them. So the matrix L is -3, -6.
Sir, is there a way to work it out though?
If you want to work it out, you can. L, you can work it out, you know, but is the
What would you take 0, 0 from W, sir, to get the answer?
the other way around. The other way around. The other way around. That's what you're actually doing. But because it's just 2 numbers, matrix L is equal to, see there? Minus W matrix. Make sense? You'll minus the W from it. It's 1 mark. That's why I didn't even think about telling you that. Because I'm thinking that I want you to reach a level. It's a 1 mark question. That means you could look and understand that it's the opposite of the numbers you need. So you don't need to be doing this for 1 mark. But you ask for it, so you'll put the W matrix there. Just take a look. See there now? 0 minus 3, minus 3. 6 minus 0 minus 6, minus 6. 0 minus minus 2, positive 2. 0 minus 5, minus 5. But I'm saying for 1 mark, you're not required to do that. But if you want to do it, fine. Because what I'm suggesting is if you look at these and you're getting all zeros and you're adding, you're thinking of how do we add a number to get 0? Add a number to another number. You have to do the opposite of the number. That's all. So that is just asking for the opposite. You could just write it, or you could do this. So you get back the same answer right here as that. Up to you. But it's 1 mark. All right. Let's continue. The 2 by 2 matrix P such that WP is that. Where's W? W, write W. Let's write. Where's W? Write W. 3, 6, -2, 3, 6, -2, 5. All right. 3, 6, -2, 5. This is W. They are saying what matrix should come here. See that? The test in your mental. Remember your this is P. What matrix should come there such that you get that? You're getting 1, 0, 0, 1. What matrix you think should come there?
Sir, all you have to do is to find its inverse.
Bam. Anybody will say that they can farm. A grade 1 farm that. Anybody will think like that. It's the inverse because you already would have learned that this is identity matrix. And what produces identity matrix is the inverse of a matrix times the matrix itself. The moment you're thinking like that, you can get it. All right? You can. There are a number of ways you can get that. All right. So then, is the inverse the one? So what is the inverse? Pull off the inverse quickly now.
Inverse. 5 over 27, 6 over 20, negative 6 over 27.
All right. Let's read the instruction first. Determine. All right. So you're going to determine the 2 by 2 matrix. All right. So in other words then, What's the determinant of W? 3 times 5 minus, I'm going to put the negative here, times 6. What do you get? 15 plus 12, 27. All right. So watch this now. It's just the matrix of finding. You're not going to work it out, you know. They just want the matrix there. So now, finally, you're gonna do the inverse of this. Let's put the adjoint of it as well. The adjoint of W is gonna be 5 up there, 3 down there, negative 6, positive 2. All right. So the inverse is gonna be 1 over 27 beside this. That's the principle. And then if you want to slide it underneath it now, you'll get 5 over 27, negative 6 over 27, 2 over 27, 3 over 27. Yep. This is the matrix P. P is that matrix. Yeah, that is the matrix, the inverse. This is the inverse of W times it would have given you 1001. Real talk. So it's the inverse of the matrix I need to prepare. Ready again? All right, let's go. B part now. A triangle. All right. A triangle. Oh, my bad. A right angle triangle M. Right angle triangle M has vertices 1, 1. You see that? When transformed by the matrix N, right? The image is M prime. Okay? Find the coordinates of the vertices of M. All right. So all they are saying is these points will be affected by this matrix to give M prime. I'm going to tell you this. You remember when we did the matrix, you did it for rotation, when you put the matrix in front of the points. All right, for example, they are telling us now that you need to use this matrix on these points. That's what they're telling you to do. And when you're done, you're gonna get the image M prime, right? When M is transformed by that image that. So transform them. 0 times, so I'm gonna work now, row by column. Row, column. So 0 times 1 is 0. 1 times, I'm just gonna work it in. 0 times 1 plus 1, 1 times 1, this is 1 at the top. 1 times 1 plus 0 times that, this is 1. So I can't say anything about that yet. Let's try the next one. 0 times 3 plus 1 times 1, 1 come at the top. 1 times 3, 3, 0 times 1. So you can see that it's actually turning them around. It's turning them around, no sign is changing or anything. So that means the next one I'm going to get 4, 3 up by the top. So the 3, 4 is going to turn into 4, 3 because you're seeing that it's turning them around. All right. So what we're looking at here is that this would have been your X prime, Y prime, Z prime. But you're going to have to write the coordinates properly. X prime is 1, 1. Y prime is 1, 3. Because you have to write them in the coordinate form because it's coordinate you get. All right. So they said find the coordinates of the vertices of M prime. The image is called M prime. The whole of this is called M prime. Those are the vertices. All right. We found them. All you have to do is to put the matrix in front and put the matrix to the left and then carry out regular multiplication. And you're good. This is not anything huge yet. Let us see what else they're coming with. Oh, there's nothing else? Okay. It's a vector question next. So we're almost done. See, we're done. Right there. Done. Is a word that we're going to have to talk about. That word. Soon finished, guys. All right, let's see what they're saying. So this is algebra now. So the last vector that we did sometime, algebra. You have to pay attention to details. It says the diagram below shows triangle OPQ in which OP is 3Q. You're seeing that. From O to P is 3Q. Also OQ. Where's OQ? OQ is V. We're seeing that. Q is the midpoint of OR. Okay. Midpoint. That means, so normally what I do, you know that I just put on the measurements. Like if I know that Q is the midpoint, this is the midpoint of OR, that means I'm going to put V right there. Because if I have V over here, that means it's V over there as well. Because it's the middle. All right. So the entire journey from O to R is 2V. Those are some little things. Next question, next part. So we have that. L is a point on OP such that, watch this now, they're saying L is a point on OP such that OL is 2/3 of P. Remember? They're telling you L is 2/3 OL. We're seeing that, you know, 2/3. Say 2/3 of it, of the entire thing. So that you can say that the entire line is 3U. And from O to L is 2/3 U, 2/3 of it. 2/3 of it. All right. Let's go for it. Question now. Write in terms of U and V an expression for LM. Where's L and N? See LM here. Arrow. Now, I know from L, look at this. L, M. I know that I could move from L to P. Also, I can move from P to M. I just don't have PM. Right? Now, I can find it. So first, they did tell us that M is the midpoint of PQ. Now I need to find PM and come back to this. Let's find PM over here. PM, not PM, PQ is to move from P to O and then move from O to Q. That's PQ. Now I'm going to go to the, I'm going the opposite direction of these arrows because I'm going to come from P coming down to O. So all of those will turn around. So I'm going to end up with a -3U, -3U, because it's 3U going the other way, the 3U's. See there? I'm going to come the other way, so it's negative. And then I'm going to plus V. So we're talking about -3U plus V. All of that is from P to Q. If M is the middle, that means from P to M is a half of that half. So then let's look at this. LM is to move from L to P in the same direction. It's just a U. But PM is going to be a half of PQ. Let me continue working. PM is going to be a half of this. -3 u plus v. It's a half of that. Imagine that you're sliding that half inside. Look at what you're going to get. You're going to get negative 3 over 2 with a u and a positive v over 2. In other words, imagine that you're sliding that half. Just look at it. So the 3 over 2 on top, but it's negative, and the v over the 2. Now, there are like terms here that you can put together. This and this are alike. And I'm going to put it aside and show you that I'm not going to waste any time with it. This is 1u, and the other one is negative 1.5u. Look at it. 3 over 2 is 1.5. So imagine I have u minus 1. So you can see that you have a negative a half coming out. So in this case, LM is going to have a negative a half u and a half v. Negative half u and positive a half v. Or you could say negative u plus v over 2 is the same thing. Or you could say negative u over 2 plus v over 2. Same thing, all of that. So that is LM. All right. So it's algebra you're doing, you know, but you have to pay attention to the information that you get from them. When they said what M is and stuff like that, you have to take those into consideration. All right. So we have a number of representation that we could write here. Any one of those you want to write would be correct. Anyone. Anyone. Next one. They want us to write PR. P to R. Where's P? Where's R? It's a long line. I'm going to use a black line. PR. They want PR. Now I'm saying to you, they want PR. I'm going to move from P to O plus O to R. Remember that we were told that Q was in the middle. So this V was V here. So the entire journey is 2V. All right. So let me create some space here and write this properly. PR. EJ, find the Benjamin. Quick. Okay. Keep it for now. Find out this. You see, I have to look at negative. So you're going to go the opposite direction. So it's going to be a negative 3u and a positive 2v. Tell me if you're not good with that.
Yes, sir.
Yeah, man, I eat that. I eat that, you know. Done. Yes, man, we're done, man. Done. All right, so that's
OR into the OQ.
OR, yes, OR. Yes, sir. I don't know where's the Q coming from, eh? OR. All right. So, technically speaking, the vector not really bad. This is the hardest type, like when they give it like this. But this, the walking and is the same. It's just the algebra. Just relax with your algebra together. So that's the question here. All right, let me write it. What did I have? Okay, I think I remember now. This, we found this to be negative 3u plus 2v. Done. This is one something they're giving you because it's not a big deal. All right. Prove that LM and R. This is collinear. They give 4 marks to this. Let me tell you what collinear is. So you probably need to write it down. When you talk about collinear, co means same, linear means line. Oh, so collinear, yeah, means the same line. So if you have 3 points on the same line, right? If you have 3 points on the same line, The only way that is possible, I'm giving you the key things that you always do every time you see this word. 1, prove they are parallel. And we know how to prove that they are parallel. Look and make sure one thing multiplied by 1 show them something else, or a factor of this one is that. Prove they are parallel, that's 1. 2, show that they have a common point. Now, I will talk to you about this. How comes parallel lines could have a common point? How comes parallel lines could have a common point? Because normally what you'd learn is if lines are parallel, they never touch. That's what you learn. So the only way lines could be parallel and have a common point is if the lines are not running like what you're thinking. What if the lines are running into each other rather than running, so parallelism is not necessarily that you can't touch. Parallelism describes the same distance apart all the time. So we're talking about this and this. The distance between them is the same forever. But imagine that if I start to minimize this distance between them. Imagine me minimizing the distance between them until it becomes one line. Then it is possible now that L, M, and R can be on the same line because I have minimized the distance between them so that they are now the same line. Have you ever take out a Word document and you take up 2 lines and you run them over each other? They're parallel, you know? Yeah, man, the parallel, man. The parallel because the distance between them is 0. So it becomes 1. All right? So we're saying that with parallelism now, with collinear, you are going to prove this and show them that after. Show them this. So what you're going to do is to take the 3 points and make 2-line segments. And I'll say to you, make sure that whatever you make already you keep. Like LM, we have LM already, you know. So we make LM. You have LM already. Guys, LM, we did it first. So we have it. We need to make 2 vectors from the 3 points. But we have, so if you have it, use LM. Let me go back for LM. LM is, see the LM is that. Negative a half U, half V. All right. That is LM. So we have this already. I'll soon show you the point I want to make. That is LM. Now you need to make, either you're going to make MR or you're going to make LR. You're going to make 1 more. All right? So look at what we have any. So they want you to prove that these points are on the same line. L, M, and R, you know, they want you to prove that they're on. That's what they want. So I'm saying, all right, let us find, why not find LR? So I'm going to move from L to R. So I'm going to come, so LR, let's look at LR. You have to find LR, which is L to O plus O to R. Easy. So that is negative 2V plus 2, negative 2U plus 2V. Tell me if you don't agree with that. That is LR, easily. Move from L to R. It's negative 2U plus 2V. That is LR. Now watch this. Come down here. Put LR beside it. LR. Negative 2U. You know, so we're going already plus 2V. I see the number that can change, that can show parallelism right now. So you're going to observe these two. Because you see everything nice, the negative link into the U already, and the positive is the V. So what we're saying is these points create vectors with them. but they're going to make sure that you have one already. So we have L to M. We now create L to R, and we're going to use it to prove collinear. Now, you do notice that the common point is L right now. See that? There's a common point already. So if I just prove that they are parallel, I'm just going to tell them that, listen, they are parallel and they have a common point L. 4 marks. So that's all they wanted to do, you know? So let me clear up here. Now, isn't it true that if you multiply LM by 4, you will get LR. Look at it.
Yes, sir.
Yeah, man, you can prove it. You don't have to prove it for CXC. This is what you need to give them. But you see, in the class, I'm just going to prove it for you. But for CXC, you don't prove it. You will know it already. So if you see it, I write it. But if you want to prove it, fine. Look at this. 4 times L. What is the LM? See there? 4 times this. Negative U over 2 plus V over 2. Distribute the 4 inside. You're going to have 4 times negative U over 2. 4 times V over 2. Look for yourself. 2 into itself, 1, 2. 2 into itself, 1, 2. 2 times negative U, negative 2U. 2 times V, positive 2V. See it here? And you could have gone another way, but we can't bother. You could have divide. You could have divide LR. You could have take quarter of LR. Another student might say, sir, I see quarter LR, you know. Give me LM. And they are correct, but I can't bother to do all. You can go that way too. So the moment you can write any one of these statements and then say to them that, watch this. When you write this or this, you only need to write one, right? So you will say to them, this would have been your proof of parallelism. So you have to write that in. So you could say LM and LR are parallel vectors and share a common point L. So you could say, you just tell them that, hello, they are collinear. Only collinear do that. So that is something that you know tonight. If they give you 3 points to prove collinear, all you have to do is to make 2 vectors using those. But they are going to give you things from your situation. More like you're going to have a vector already with those letters. Make 1 more from it and you can. And after you make it, observe it. You're going to realize that you can multiply by a fraction or by a whole number and get another one and get the other one. The moment you do that, then you write a statement. Always, guys, take this statement to be something that you can write down and use it back. You just change the letters. So you just say vectors LM and LR are parallel vectors. You tell them that because you would have proved it up here already and share a common point. The common point will be there. They are collinear. Done. So much marks to give you for that? 4. And I believe this is the end of the test.